I said both of my titles, right? I think so. Let's see what the title is over here on YouTube. It's going to take a second for it to spool up. Spool up. I said spool up. Okay, that one's going. Modular stuff. Okay, got the right one. Check on YouTube. There we go. Modular stuff. Open up the stream, mute myself so we don't have repeat audio, and then pop out the chat. Pop it out. There we go. I can close that window. More resources on my poor 1080 FTW in this computer. Mark those as red. I had that big raid from the aquaponics Twitch, and it didn't show up as anything because, you know, Twitch being its usual self glitched out and showed nobody coming in. All right, let's see. So we got YouTube popped out. Twitch, I'm gonna hit refresh on, and we'll make sure that my title's still in there. Bada bing, it is indeed. Thank you for the follow. I usually don't announce follows, but there's nobody here yet. Nobody's here. Okay, we're up to date. I'm doing John B as the background music. He was big in the early 2000s, back when we were all watching Flash animations. Let's see. Okay, cool. I think I'm all set with that stuff. How's everybody doing? It's been kind of a busy couple days. Everything's always busy because I'm doing the VOD uploads. I got 140 to go, and that number's not going down as fast as I'd like it to. I really need to push through this before I burn out. I've been doing programming in the background as well. Been trying to resolve Hajiwo's coding. I don't know where that guy learned to code, but it's not done right. And when we do stuff like flip to a different microcontroller, you can't do that if the pin numbers are in the body of the code. And you know, Hajiwo does amazing work and his stuff works, so I'm not faulting him for that by any means. But like, if he did the stuff from the beginning correct, it would probably be much easier on my end. much easier on my end. But anyway, this is getting me familiar with the code anyway. I've already rewritten a Hajiwo project. That would be this VCO right here. And I like the code that I wrote for it. I need to put in an LED flashing engine into this code so that it works finally, so I can actually have a VCO. And then I guess, you know, 2 little edits to the circuit board. Well, three mistakes. Edits to the circuit board do not make a completely new module. I think I will not order new circuit boards. I'll make 3 of these VCOs and I'll give them to my friends. I have the corrections in Fusion, so I can put the Fusion files up on GitHub or something of that nature, and then you guys will have access to them. But it's an RP2040 that is being a VCO. It could probably be a variety of other stuff too, depending on, you know, what you do with that analog input. Because you can scan that analog input and you can make it do weird stuff, like filter stuff or sequencing stuff, etc. In that same vein, we have to build up the yellow circuit board, which will be the chord VCO. That scares me because I don't know what the hell's going to happen with that one. I don't know how that engine utilizes chords, and it's going to get into like music theory stuff. So that's going to be a hell of a thing. How's the universe treating you today? It's so humid here. The AC might be being turned on, but I have a fan at my back, and there's just steam coming off of me. It's so humid. Other than that, things are great. Dog's back. I've been hanging out with the puppy. She's been coming down here because it's cold down here, and escaping the humidity, sitting in front of my fan. So I've had a little buddy with me the whole time. I've had a corgi at my feet. You can check out the Discord if you want to see pictures, because I take a gross number of pictures. Cold and gloomy over here. It's the East Coast is just gloom, gloom, gloom right now. We've got a lot of like rainstorms moving through and stuff like that, which really messes with me because of my skeleton and all the breaking of my skeleton that happened last year. So when it gets like pressury and humid, I'm just miserable. So I've been a little bit miserable. Yeah, humidity in a basement. I don't really have a dehumidifier down here. The humidity, though, as reported by probably a pretty inaccurate sensor, is 63%. It says that it is 72.5 degrees down here and 63% humidity. I have a fan on me and it feels like air conditioning. Yeah, the Northeast gets extremely humid, northeast of America. I've been doing a lot of work in the background. I've been doing a lot of uploading that is really kind of breaking me right now. I would love to stop doing it for like a couple weeks, but I have 140 out of 350 to upload still, which, you know, it's getting there. It's getting done. That 3 became a 2, the 2 became a 1. The 1 is sticking around for too long, but I'm beyond halfway through the 1. Getting down to 99 will be a momentous occasion in my mind. But yeah, I'm going to get those uploaded and then figure out what I'm doing in terms of video editing. In the meantime, I've been doing a lot of work in Fusion 360 and trying to make an RC car body in Fusion 360. It's been a lot of work, and I'm discovering what my processes should be. If the thing that I want to try works, then maybe we can do a day of Fusion 360, and I can do a little tutorial about the methods that I've worked on and figured out. Because there's a whole process to it, but I'll be able to take a model of a car and turn it into an RC car body to 3D print. So it can be just about anything. That'll be pretty cool. But there's a lot of work to it. It's like, how do you define the inside surface of a car, of a vehicle? And there's ways to do it in like Blender, where you basically multiply the amount of triangles by a billion. I have a low poly model. It's like Super Nintendo number of polygons. And in order to do that sort of inside fill thing, it bumps it up to be gigabytes in Blender. Whereas in Fusion, I can have it do a process that probably resembles what's called alpha blend. Alpha wrap. Alpha wrap is when you take a virtual ball bearing and you wrap it around every surface of your solid, and that gives you a closed solid. So if you make that ball bearing infinitely small, then it will give you a slight increase in the thickness of the object, but it'll be a closed space, and any little gaps the ball bearing will go over and remain closed, right? It'll take a buggy model and turn it into something that is a closed solid with a billion polygons to it. And no sense at all to the polygons. They're kind of a little random. They're not like if you went in and designed where all your polygons should be, and then you alpha wrap it, you will have just a mesh coating, and it'll be kind of a disorganized mesh coating. Not even necessarily symmetrical. So I've been playing around with that, but I think Fusion, when it does its core kind of thing, where it makes like a cutout, like it can hollow out. If you take a box and you use this thing and you give it 1 millimeter, it'll give you a 1 millimeter border around the outside edge of the box and make a consistent solid inside, a consistent opening inside that you can work in. So I think Fusion does a little bit of that. I think it does a little bit of a alpha whatever wrap. But I'm learning about this stuff. It's not all consistent yet. I don't know my processes. Probably pretty easy to do if I knew what I was doing, but I'm also learning Blender on the side. So 6 of one, half dozen of the other, right? That's what I've been working on for most of the weekend, aside from uploads. Ugh, there's still so much to do. I want to get some stuff off of my table here, you know? We've got too many different things, too many fires burning in too many different directions. And one of them is a direction that I want to get resolved soon, which is synthesizer stuff, because Dave and Julian are going to be in summertime mode soon. They're usually in school mode during the winter, so we've got summertime Dave and Julian. I want to get them back in here. I would be jazzed if we can actually fix this module. I don't know what the hell is wrong with it. Yeah, it overpowered. Keeper of Maps says, yay, summertime mode. Keeper of Maps, thank you for the 52 months. I really appreciate you being here, man. I do. I do. We're listening to John B right now because I had absolutely no other inspiration to play for music. It's a little drum and bossy. Or drum and a boss. But yeah, summer's hitting hard. I thought it was going to be a nice, cool summer at first because it started off a little bit cool, but then it hit like a ton of bricks. The pepper plants, I don't remember when I planted them. I put them on an auto light. So I have dusk and dawn switch the light on and off accordingly, right? According to City Hall, Philadelphia, whatever the coordinates are for City Hall, those dictate what the day-night cycle is of my plants. They're in a planter. They've got like a lid on it, a clear lid, and 2 grow lights. 2 grow lights keeps it kind of warm, right? Keeps pretty warm in there. They're peppers. They should get warm. They should get exceedingly warm. They should have like 80 degrees at all times, and they kind of do. And they're in the basement. They're behind me under a table, actually behind a wall and under a table. But I've been making sure that the soil stays moist. It stays moist for quite a long time because it evaporates into that container and then drips down. And they haven't grown at all. Nothing has happened. Nothing. There's no seedlings. There's just nothing. There's nothing there. There's nothing. John B's talking. Whoops. Maybe I'm part pepper plant. My folks are getting older and they have less blood circulation, and so they'll sit and watch TV all night, and it gets hot in the room, and I'm like sweating, and they're like, it's cold in here. First of all, put on socks. Second of all, what the heck? Move your body around. It's ridiculous. I am a cool weather advocate. I would live in the Arctic Circle if I could. I like my cold weather. Not really, I've seen what the procedure is for taking a dog for a walk in the Arctic Circle. It is a ridiculous amount of suiting up in order to get everybody outside. I don't think I would like to live like that. But I mean, just like a colder climate. Starting seeds can be a pain in the butt. The first time I did it, it was so easy. It was so easy. I just put seeds in a little bit of dirt, and I watered the watering thing. The thing is, my seed starter doesn't have that fabric, the fiber wick to take water up to the little planters, so I need to water them. It's possible that I overwatered them, but the soil has just been moist. Maybe too moist, because it holds it moist for way too long. But, I mean, I'm starting the seeds. They should be wet. Maybe I'll have to get one of the ones with that fiber thing on it. Or my seeds are dead. I don't know. It's just like nothing is happening with it at all. Very strange. I found a button. Oh, you subbed with the driving emote. Thank you, Copper. 16 months. Hey, I appreciate that 16 months. You're a good dude. I have John B playing. I have no inspiration, and I was just thinking, and I was like, well, Gonad plays this stuff a lot. So I just put that on in the background. It's early 2000s Drummond Boss. Oh, a level 1 hype train. Hey, that's nice. Whoa, because of Bovanet. Boavanet. Thank you for the prime. Hey, those primes, nobody's going to remind you to take the lollipop out of Jeff Bezos' mouth. Nobody's going to remind you of that. And it's good on you. Thank you for the prime. Sub ends in 19 days. Oh, you just haven't... Hey, whatever. I'll still thank you for it. There's no point in shaving off that compliment. 100 bits for a hype train. Aww. Thank you, guys. Keeper of maps. That is $1 in my pocket. Well, it's a little less than $1 in my pocket. The Twitch still scrapes off a little bit from everything. Twitch has to have its tithings, its pound of flesh. We got Dave's module here. We're going to do some reverse engineering. And since this thing blowed up because Dave put power into it wrong, I'm calling it an IED. What the heck is... That's an existential horror kind of emote. Modern church corporate tithings, yeah, pretty much. I gotta wear my hair shirt. I don't know, if I show the John B stream, John B has been very open about being like, yeah, don't worry about it, just play my music during your stream, it doesn't matter. But like, I've shown things and had YouTube be like, I can't show that anywhere now. You need to delete that shit. It's like a visual copyright. It's so ridiculous. That was for that Prodigy video, the stop motion one. Boom, leg shot. Boom, leg shot. Hey, 9 months. When did that happen? Thank you. 9 months. Man, we got everybody coming out of, well, not the woodwork, but I mean, we just have people coming out. It's nice. Pepper seeds need aerated soil, moisture, and warmth. They're getting all of that, man. The soil is loosely packed, so and it's new planting soil from, I guess, the hardware store. I think it's Miracle Grow, so it has food in the soil. Loosely packed fibrous earth. it has warmth, it has plenty of water, and those lights are bearing down on it. I think that's where a lot of the heat's coming from. So, but they've been like that for like 3 weeks, and not a single one has started to germinate. I don't see a single seedling popping up at all. Like, I don't understand it one singular bit. Why is this thing in alert mode? Okay, my dog's barking at the door. Sounds like bad seeds. The seeds that I have were partially left over, and then the other seeds that I planted were for the habanadas. And the last time I got habanadas, they didn't grow at all. And so these may not be growing at all. I hear they're very ornery. Maybe I need to start them in like a paper towel first. But I thought that they would start. I mean, they were brand new seeds, right? I bought them, had them shipped over here for the habanadas. And then the rest of the seeds have been in the freezer all year. But I don't think that would kill them. Got told by a gardener neighbor that they got higher sprouting rates by running the seeds in an ultrasonic cleaner. I have an ultrasonic cleaner. What do you do? Because I have one now. That would be an interesting thing. What, do I put them in a plastic bag and then run the ultrasonic cleaner for a little bit and then kind of like jostles them awake? That'd be a crazy thing. When I got really good sprouting rates, I actually planted them 2 by 2. So I put 2 seeds in each planter, and I got 2 plants out of each bin, which made it a little bit weird, but I don't know if maybe the plants would get into like competition with each other. They were the same plant. There were just 2 seeds in each bin. Paper towel trick has always worked really well for me. I don't know what it is. What do? You wet a paper towel, and then you put the seeds on the paper towel, and blast them with light, and they'll eventually start sprouting, and then you pop them into the soil carefully. Because I don't know what it is. I just saw it on a subreddit when I was browsing through. That's where I get a lot of my stupid knowledge. Just like clicking through stuff. Yeah, I don't know, man. I could go put opera music, like speakers with opera music blasting at them, if that would do anything. It's I think vibration of some kind encourages the plants, but damp towel, seeds in the fold, kept in a plastic bag for a few days / weeks. I probably should have done that. The scale of it would have been huge because there's something like 64 plants there. A Bridgewater subbing with a tier 1 for 45 months. Hey, Bridgewater, thank you so much. Oh, did I say 9 months for Boom Leg Shot? Because that's 9 months. Thank you. Thank you, guys. I appreciate you, those of you that have stuck with me over this lull in between boards. I know it's been years, but, you know, it's a big project. I would challenge the people who think I should be constantly working on Burn the Subs to build something of the scale of Burn the Subs and share it in the Discord. And then I will take criticism from you. People have been a little snippy with me about getting Burn the Subs done, and I don't know what the hell is going on. No terrible joke this time. You know, maybe that's what I felt. I felt the absence of it in the air. Oh, we got a hype train emote, and it's another terrible Twitch emote. What is this thing? Is that a frog with a ... over its head? Strange. An hour or so in the ultrasonic cleaner. I mean, I guess I could do that. I could try that next time. That would be an interesting science-y kind of thing to do with my pepper seeds. I think it's a little too late in the season already, though, isn't it? If I start seeds now, it would be... I don't think I would get much time with them. When did I start last year? Yeah, what is the joke? What is it? Frog Ponder. Oh, I was like, all right, is this going to be a difficult one to get? No, it's not. But it's a balloon animal. It's from Sharp Balloons, an artist. Weird. How do I get one of my emotes to be on the main rotation, huh? I guess I got to work with Twitch corporate. You can get a hype train emote. You got robbed. Maybe you already have it. Yeah, it does kind of a waste of an animated emote because all that's being animated is the 3 dots. You can do so much better with this. I mean, like, we see better. It's right here. You can get into a banana costume and make an animated emote. I mean, come on. John B. and that brake core, man. Existential horrors beyond comprehension. That's what I get to look at when I'm streaming. I don't think there's anybody from YouTube yet. I don't see no YouTube logos. Let's see, where's the YouTube monitoring? Yeah, looking lively. I'm not cool enough to have YouTube subs yet. Maybe that'll change when I start editing content. That's sort of the big hope here, but it might just be that I've hit my plateau. You know, you got so much in you. You have that big push. You grow an audience. I got a lot further than I ever thought I would get, but I think I plateaued. The only way for me to get around that, go viral, or possibly just doing... Wait, that's for being part of a level 100 hype. Yeah, I think we've gotten to 5 when Burn the Subs was in full swing. Getting Burn the Subs back up will get more people in here. And then I think editing YouTube videos. I need to make like 10, 15, 20-minute videos on projects. Maybe not a whole project of video. It depends on the project. Maybe I should zero in on those one streamer projects first. And then I can kind of get my style down. Because it's going to take me a little bit. It's going to take me a couple videos to get the style down. The same thing happened with the VODs. I got back into the swing of making thumbnails. I got back into the swing of, you know, making all of the specific comments that need to be made, all that stuff. I found you through one of the racing wheel vids on YouTube in my recommendations. Oh, that's awesome. Yeah, the racing wheel's sitting behind me still. It's collecting dust currently. I need to plug it back in, and we need to do some like My Summer Car with it or something useful, right? I don't know about big serious racing games. I want like weird stupid racing games, which it's likely we could find a couple weird stupid racing games, but then do they have the right kind of force feedback on them? The Strange Parts interview. I don't think anybody found my channel through the Strange Parts interview. I don't know though, but it was pretty cool to swing by that guy and actually get a little recognition, I should say, because Twitch is quiet. We don't see a lot of big creators here, and if we do, they're usually pretty insular. They kind of stick to their own. And having Strange Parts come in and go, "Yo, it's Oh Bother," I'm like, "What the? Who am I? Like, how do you know me?" It's pretty cool. That's pretty cool. A little starstruck, you know. Play some Crazy Taxi. I didn't play much Crazy Taxi. I watched friends play a lot of Crazy Taxi. Yeah, there was a brief little interview because of the steering wheel stuff. Flatulent Gonad was actually watching Strange Parts, and Strange Parts made his foray into Twitch for a little while. I was kind of like watching him and monitoring that, and I was like, oh, that's pretty cool. He's here. And then Gonad ended up watching his stream, and they were talking about wheel stuff and force feedback stuff. And so he was like, this is like completely up your alley. And then I guess either he talked to somebody or their like Discord moderator, somebody like that contacted me. And I was like, oh shit. So I actually like went on the show and talked about some of the stuff that I was doing. The guy he had on was way cooler than me though. He was way cooler than me. He had a shifter that had XY feedback with the motors, similar to the way that the steering wheel controller works, except it was a shifter or joystick. And so the shifter, you could program the feedback to make it feel like you have a variety of different shifters. So if you're in like a big rig, you could have like 16 gears, right? Or if you're in like a backhoe, it could feel like a hydraulic lever. Or if you're in an 8-speed race car, you would have all 8 of the gated feeds. You could make it feel like plastic. You could make it feel like metal. That's so cool. It takes a lot of doing, but that's what that person was making. That's really cool because you could turn that into just about anything that is a lever in a game. That was super cool. The Wheelman. It's no, it's servo motors. So when you have just like a servo motor and you know what the position of the servo motor is, you can control the force on it and just resist torque, or you can move the lever into a location. So if there's a certain amount of torque, you can resist that torque and stop the motion with energy, just magnetic energy. And so that's sort of what they're doing there. It's the same way the force feedback wheels work. You know the position of the steering wheel, and you've got this motor that will then fight the movement of the wheel. And so you can use that and sort of the way that we're really good at manipulating electromagnetic fields in order to produce a variety of different feedbacks for the user. So you can have it feel like you've slammed into a metal retaining, gate for the gear, and you can make it feel like you're popping synchros and stuff like that. You can even make it feel like you're grinding synchros, which I think would be awesome in a game like My Summer Car. So you can go clunk, and it would feel just like you're slamming into a gear. In a proper situation, a simulation situation. In a proper simulation, that would be very, very cool. Where'd John B go? Oh, he's behind here. There we go. I know, right? Seeing the code for that. I don't know anything about force feedback, though. I don't know anything about the specific coding of force feedback. I just ran the open wheel project and sort of ran with it. Wow, my Furby looks really cracked out, doesn't it? What I need to do is I need to hook up some more show bits and bobs. The clutter needs to come to life. I need to be able to have this Nixie tube turn on when I'm streaming. It's covered in dust. The whole point of this rack was to keep dust from forming. Keep dust from getting all over my stuff. But my stuff is very dusty now. This whole thing needs to be broken apart and put back together again. I think I also probably need to get a taller one. I need to just, if Burn the Subs actually starts making me a little bit of money, we either need to rebuild this rack with frame rails, or I need to buy the larger version of this one. And then I could move this one back to the internet or something, the internet area. I'm not sure yet. The electrostatic. No. This is just by volume of air moving through the server. By volume of air moving through the streaming computer there, and then the file server down there. That's just where all of the dust is settling. Dust and dog hair. 80/20 rack. The only problem with doing an 80/20 rack is that I wouldn't be able to get behind it. This one is on wheels on the desk. There's wheels down there. And so I can spin this thing around and get to the back end. I mean, I could put an 80/20 rack on a big turntable. Did I end it? No. Work continues. Yeah, I guess you can get 80/20 casters. You can use any caster you want on 80/20 rail. No, Burn the Subs is not ended. It's just under a pile of stuff. I have a giant Lazy Susan bearing. I was going to use that on a biking project. But yeah, the Burn the Subs is up there. It's on my wall. I need to do a lot of work on it, and I will be doing work on it. We're going to work on it Thursday. At the very least once a week. I need to force myself to work on that project because I'm a little burnt-outy on it. But there's a lot of fun stuff to do. We have a lot of exciting stuff to do. Now that we've vetted out the laser, and I can finally put a pin in that one and say it's done, we have the ability now to work on the rest of it. So that was bugging me for a while. I was like, how am I going to cool the laser? Nothing we've tried is working. UV epoxy and applying it with a tiny little syringe and just making sure that all of the right openings are openinged worked out. That worked out great. It's actually quite nice. Hopefully the epoxy and the plastic aren't expanding and contracting at different rates, because I do not want it to break off and explode. So, and then on synthesizer stuff, I have a lot of programming work to do. I didn't do programming this weekend. This weekend, I wanted to kind of crack the egg of Blender and Fusion and try to figure out how to quickly make the outside wall of a car model into an RC car shell. And I did not succeed, but I think I'm this close to a solution. Chester Willard, who you guys see in chat often, he's in New Jersey. Chester Willard hopped in and tried a couple things as well, but I'm not using that method. His method creates a lot of junk data, and it ups the polygon count of something that doesn't need it. You know, the files are tiny that I'm using. I'm using a low poly model because it looks cool to make a cool looking RC car body. And I do wish that I could make it more accurately though, so that the walls were actually, you know, they looked low poly. It's still going to look like a 3D printed RC car, right? No matter what I do to it. But what I'd like to do is be able to take a generic car shell and turn it into an RC car model, which means thin walling the entire outside, and there's often gaps and stuff. So I need to find a method for doing that. I think I have. I think I found a method for doing that. There's one method where I use Mesh Labs and I alpha wrap the whole model and get rid of all of the outside facing stuff and replace it with the original. That's not as good, I think. I don't know. And then there's the method that I haven't tried yet, which is to use Fusion 360's tools in order to make a hollowed out solid out of it. I know that you wouldn't download a car. What up, Wonky Robot? How you doing? I know it seems like you're hello world. I've been talking to Twitch the whole time. You're the first comment on YouTube. It's a lonely place, but we got you up on screen at least with everybody else. So maybe this feels like a little bit more populated. We have trouble here because I don't have that many viewers. I don't have that many people watching, so we don't have a constant roll of chat. It'd be interesting if it ever happens to get enough people to have a constant chat rolling by. But we're dipping into the territory where if you say a bunch of stuff, it just sits. A slowly more exclusive. Oh, that's a good way of looking at it. Welcome to the YouTube VIP lounge. Yeah, it's like I absolutely would download a car, like without question. There was a leak at some point where BMW had all of the files for a car that you could download. It got on like a torrent or something like that. It was many gigabytes of information. I think a bunch of my friends downloaded it just because of that anti-piracy ad. Like, you bet your ass I would download a car. Are you kidding me? Yeah, we got Drummond Boss going right now. We're trying to get into the reverse engineering mood. Open source car? Like a consumer? Like a real car? Looking for a BIW model for my car for so long. Do have one of the EV Hummer. That's kind of cool. Yeah, it'd be crazy to get the original design files for like your whole car. That'd be absolutely crazy. One thing that I love that's happening now is people are getting like these old designery old cars and converting them to electric, which is great because those old cars are just light shells. And so you put this balls out electric motor into a light shell, and you have an EV that's actually capable of doing some miles and also capable of getting out of its own way, as is typical with EVs, because electric motors make maximum torque at a standstill. So it's very easy to get a motor and batteries that are able to get themselves up to pretty decent speeds. Oh, you've heard of the open source car channel? Yeah, better carbon footprint because you're not lugging around all that weight. I would love to do that. I would in 1 second, I would make this whole channel. I would turn this whole channel around. I'd hit the brakes on the channel. I'd pop that wheel, ball a UE, burn rubber. What other stuff can I say? I would turn this channel around and I would buy a classic car and turn it into an EV. Miles per kilowatt. Yeah, I wonder, how do you measure that? People just want to know distance, but like, could I import something from Euroland for cheap enough? We could get like an E36, not 46, no. like 36 station wagon BMW and drop all the stuff out, put an electric motor in the back, put a bunch of batteries in the front, call it a day. Sorry, frunk. Turn it into a frunk. That'd be pretty cool. Old 65 Nova's an electric car. I saw it was like an E30 or even like whatever the 1970s BMW was, and somebody made that into an EV. Even though I think at some point BMW had E30 electric cars for that brief little period in time when we tootled with electric cars in the 70s because of money. You remember this guy, right? FK? You remember this guy in his nose? Oh yeah, clean that nose off. This guy from the early 2000s. I had absolutely no inspiration at all for what music I should play. I was like, what am I going to play? Like, nothing seemed right. And even this doesn't quite seem right. I'm just doing it to fill space in the background. But I was like, what am I going to play? I'm going to wash my hands. But yeah, so I was like, all right, John B. John B has a very good attitude about people streaming his music. So, it's not like I don't give like absolute fundamental credit for what I'm playing here during the intros. But yeah, Flatulent Gonad's been playing a lot of his stuff, so I'm like, yeah, it's cool. Oh, the guys that make their own battery power walls, yeah, battery packs that slightly use 18650s. The 18650, the thing about the 18650 is that you have your slab lithium-ion batteries, right? But those aren't as energy dense. Hold on, I'm gonna cut and paste that recommendation. Cut and paste that into a browser for later. Oh, that looks very green. What the thing about energy density and lithium-ion batteries, like the slab batteries are not as efficient because they're not under pressure. The 18650s are. So the 18650s are rolled under pressure. So even though you have that packing problem of spheres, you have a sphere packing problem with many inefficiencies in it. Whereas the slab batteries, you just big slab. It's a big chunk of lithium ion. But with those, they're actually a lot more energy dense in spite of all the empty space. So that's why you have like a lot of older electric cars have tons of them, tons of these 18650. I do this because it's a cylinder, but tons of 18650 batteries in a big bank. There's many other ways to do it nowadays. But what happens is those go bad, and we've had several people in our Discord. We get it, you vape. Vaping hurts. I don't like it. I don't understand. Like water particles, my favorite thing to inhale. But yeah, so you get very dense packed batteries. They go bad after a while, and we had several people in the community here who were building power walls, and there were some very exciting fires that they had too. Yeah, there's a lot of look, jokes bounce off of me, all right? Why are my battery slabs so puffy? Yeah, I ran into that with a couple batteries around here. But the bag that's around the battery is supposed to be able to contain the volume of hydrogen the battery can produce. So if your battery goes puffy, don't poke it with a fork. Like, just don't do that. Because if you poke it with a fork, that can penetrate layers, short them out, cause a spark. That'll cause a fire. If you don't do that, if you just leave it alone, you're fine. I had a little tiny RC car battery around here that I was poking with a pin tool just right in front of everybody, and it was fine. Yeah, I actually need to find a battery collection, like a township collection thing, because that's what's in there. That's full of lithium ions from drones, and drone batteries are too big for the little tiny RC car stuff that I've been doing. So this is too much. That's why it's in an ammo can, because an ammo can contain a little bit of fire and spiciness. For one of the FBI demonstrations, what they would do is they would put a detonator in an ammo can and just set it off remotely, just to show you what an actual explosives detonator can do. And let me tell you, we were in bleachers very far away from the ammo can that detonated. The ammo can was this tiny little thing way off on a dirt road, and it went 12 to 14 feet vertically in the air from having just one detonator. And when those guys are setting stuff up, they're holding a cluster of like 50 of these detonators to, put them into something in order to make pyrotechnics. One of those things, ammo can, 16 feet in the air. There was no shrapnel because the ammo can pops open and distorts and stuff like that. And the thing is, like, any explosion that's going to create shrapnel, they have out of view. So you're not looking directly at it when it explodes. But yeah, it's a couple M80s. They're designed to set off higher explosives. So you have your explosives that are stable enough that you can literally light them on fire with a lighter and light your cigarette with that, or heat your coffee up. But if it gets hit with the energy, it's really it's all about energy at that point. The energy of a detonator, then it goes off. Fun stuff. Or not fun stuff. It depends on where you are in relation to the stuff. John Beta does stream on Twitch, by the way. You guys should check out his Twitch if you get a chance. All right. We're not doing anything exciting today, so we might as well get started. Is that what it takes? I don't know. Let's get started. I had quite a time. I was doing a lot of 3D modeling over the weekend, trying to figure out how to take a low poly car body and give it just a little bit of thickness, because I had all polygons that were all outside edges of the car body. Everything on the inside was deleted, and so it's a very specific problem to try to thicken something like that. And there are tools to do it, but they're all just a little bit different than what I needed. And so I was learning Blender, I was learning Fusion 360, I was getting to the bottom of the process, alpha wrapping, creating hollow solids and stuff like that. But yeah, the I didn't get to the actual solution of my modeling problem. I think I'm this close to finding a method of taking just like a 3D model of a car, gutting it, and then making it into a shell for an RC car. And I could probably do that with some very lazy methods, but it wouldn't quite be the right thing. So I think I'm zeroing in on it, but that thing took most of my time this weekend, aside from uploading videos. I am still uploading videos. I've got about 140 to go. 140 videos left out of 350. And I got to mark down all the stuff that's happening during the video. And I can do about 3 a day if I really concentrate, but I'm burning out. I'm burning out bad. It's a good lesson in burning out. Once I'm done that, I'm going to start focusing in on, yeah, the shell function works great, except if you have multiple faces of the thing you're going to hollow out. Otherwise, it's just going to so my method on that is to actually put the car on like a trophy base where I've got a solid flat on the bottom, and then turn it into as much of a fusion solid as I can, and then I can hollow it all out. You know, this guy comes in here with this cat emote just as I'm finishing. I just paused the John B background music that I'm playing because I thought of your streams, and I was like, yeah, John B's pretty cool about streaming, you know, for background music. Anyway, just woke up from power snooze. I cannot put my finger on your freaking weird ass sleep schedule. But yeah, basically, what I'm trying to do is get something to make the inside face of an outside face to model. And the outside face has so much detail that I don't need. So things like alpha wrap, things like the, what was it called? The shell function of Fusion. I think the shell function of Fusion, most things in Fusion are a lot more complicated than they let on to. They make this very simple user interface that does some very advanced stuff. And I think the shell function is one of those functions. I think it's using like alpha wrap and some other techniques in order to create an inside edge on meshes when you use it on meshes. But I think what I'd like to do is try using that. And basically, in order to make that work properly, I'm going to put it on a square pedestal or a box pedestal. And then it'll hollow it out. And then I can come in from the side with a sketch that is projections of the body edges and cut off the base, and then I'll have it. You can cheat it with surfaces and shell commands. What I was able to do is use a shell command on the inside only part, and it made an inside out like sponge inside of the car body. And I was going to delete all the vectors, but then I'd have to go through in Blender and meld all of the individual vector points, which is fine because it's low poly. But if it wasn't low poly, that would be a hell of a job. So I think doing the larger operation like I just described, and I haven't tried it yet. I don't want to do a 3D modeling stream today, although that would be very interesting and it's what I've been working on, and maybe I could finally resolve something and get something done. We're going to work on Dave's module. We're going to work on Dave's module because it's been sitting and collecting dust for a little while. We're doing some hardcore reverse engineering, which is near and dear to my career. Anyway, so for 10 years, I'm going to say 10 because I'm just rounding up. I wish it had lasted 2 years longer, and then I could say for 10 years of my life. Before doing all this media shit, I decided that I would put some mileage on my soul and get a little bit of industry experience. Not to mention the fact that at the time, he's he's probably around, but FK Productions was constantly coming to me with weird projects to do for festivals, and it was awesome. So I was able to get my artistic side expressed doing festival stuff, but at the same time, I was in industry, reverse engineering, terrorist electronics was the description. It's mostly basically we had to put on cotton gloves, and they threw circuits at us, and they said, how does this work? And so we had to look at how previous versions of the same circuit work, because there was like an evolution of circuits, and there were some very smart people over there doing some very sinister stuff. All we did was categorize the devices. We figured out, how do they work? How do they trigger? What's the sequence behind them? What does this do? What are the RF properties? What are this, that, the other thing, right? We put all of that various bits of data into a big report that was a technical report that looked like only one person had written it. So they had a bunch of engineers writing, which is a lot of the contention of the job, because when it was a very academic job, and we were like, ooh, what's this new thing? It was a lot of fun, and we actually were able to do a lot of very meaningful work. And then it became an algorithm, and then that algorithm got written down as an SOP. Those of you out there who are working, I know some of you listen to my stream at work. Here's a little thing. If they start talking about SOPs, definitely go over your resume a couple times, right? Because SOPs mean what they want is a document that says, hey, this semi-successful business, yeah, they're disgusting. This semi-successful business has been turned into an algorithm. And that algorithm we put in a file cabinet, and we fired the filing cabinet out of a cannon, and it landed in the woods, and another successful company popped up there. That's what they're essentially trying to do sometimes with stuff like that. So the writing was on the wall. The SOPs started to be talked about almost exclusively by all of management, and then we got underbid by another contractor. So, but that's how it went out. During the heyday of the IED stuff, there was some very interesting stuff going on. I didn't get paid shit to do that though. They brought in a bunch of fresh out of college kids, so they didn't have to pay us. Performance improvement plans. I didn't get quite that far because the contracting company had all that stuff baked in, and there was sort of a process where if you weren't improving it at a certain rate, you could get dropped for that reason. It was very contracty kind of stuff. It was funny because I got thrown into a lot of management stuff that there was just no training for at all. Like one day, all of a sudden I was giving somebody a performance review, and there are things that you can't say in performance reviews. You will be in violation of the law. Like, I didn't get any training on that. Do managers typically get trained? What happens there? But yeah, SOPs are for either dumbing down the people doing the work, or and paying them less, obviously, or for shuttering the operation and having it able to start up again. So that kind of stuff was happening at the later days of that job. But anyway, during the heyday of that, I was reverse engineering IEDs. And like I say on this show, I try to teach you guys a little bit about how this stuff... Okay, accountability tracking. Oh, that means that they want to fire you without paying taxes. Yes. I've been through that one before too, where I get shit canned by a company, and then I sit down and I put my little hat on, and then I open up the documents for my state that say exactly under what conditions you get unemployment. And I was like, this one, this one, this one, this one, this one, this one. So I wrote a paragraph on my unemployment stuff that surreptitiously, is that the right word? Anyway, I vaguely covered all of those in order in a paragraph. I was able to cover all of the conditions that weren't met. And so I got unemployment. It's like, don't mess with engineers. We're very clerical about things. Oh, that's the wrong one. This is the one I wanted. Yeah, well, anyway, so I got fired out of a cannon into the sun. Ended up back here and ended up finally being able to do media stuff. So I got 10 years of experience reverse engineering things. Not audio things, not even necessarily analog things, but I do have experience in reverse engineering. And reverse engineering can be very boring, in fact. Reverse engineering requires a little bit of experience in circuits, knowing how people design things, and you get that from taking stuff apart and reverse engineering it. So it's very cyclical. I mean, what you should basically do, if you're interested in being able to reverse engineer, and for Christ's sake, you're watching my channel, so I guess that's a pretty good assumption, take stuff apart. Eventually, stuff will start going back together and working again, although there may be a grace period of a little while, because I used to take stuff apart as a kid, look at all the pretty circuit stuff. It would never go back together, and it would never work again. Are we still missing a screw from this thing? I remember we were missing a screw. I'm going to have to replace these screws with other screws. I only have 2. Oh, my God. I need to buy more of these, too, my little black knobs. These things are great. Alibaba. They're as cheap as can be. Simply knurled, tiny little knob. And that's sort of the look of the synthesizer. One thing that we will get into eventually that I'm excited about is this right here. Sanitary wet wipes. Wait a minute. No. This thing right here. This is a printer. This is an ink tank printer. And the cool thing about an ink tank printer, and I haven't quite figured out where to buy it yet, is that you can get ultraviolet inks. And if you get ultraviolet inks, you can also do the things we do, like little needly little reverse engineering little bastardy things where you fool something into thinking stuff is happening. You can fool the printer into thinking that it's actually passing a page successfully. Instead of passing a page successfully, what's happening is you're advancing a linear table across the print head. And what that means is that on flat objects, I will be able to print in full color ultraviolet epoxy. Now you can buy these off the shelf, right? But they're like $5,000. I don't have that kind of money for printers. Printing is expensive and it's annoying. The ink I've found are tanks of UV ink that are like $300. So I don't know what I'm going to do about that. Getting the ink itself is out of my expense. I'm in the tier where if it's like a $100 purchase, I can kind of grip my teeth and purchase it. And anything above that, I have to just kind of like sit on. I can't really do it. I've made some pretty big purchases. You know, the big 4.0 got me the nice oscilloscope. But other than that, it's like we gotta watch it. We gotta get Burn the Subs back up, and then I'll have a little bit more leniency in doing things like that. But I wanted to do that because I want to do that. I want to build a CNC. I got out the old Burn the Subs frame. The old Burn the Subs frame is that motion stuff you see at the bottom here. Let me go point it out. This stuff down here. This is the old Burn the Subs test, the axis test. It's like the shittiest axis in the world, but it is a roller axis. And if I can get maybe a couple more frame rails, or we do the challenge of I can only use stuff that I have, because I've got a router for this. I've got an AC router, and we've got servos that we can use on this thing. So we might be able to get that up and running as a CNC. And if I do all that stuff, then I can do carbon fiber front panels for the synthesizer with full color prints on them. And I can print anime panels and put them up on there with a bunch of TNA just right there on the front of the synthesizer. Or I can take a more sensible approach and just label them. But just found UV inks on AliExpress. 1 liter, $40. That's not so bad. That's not so bad. Yeah, full anime titties on the whole synthesizer. That's the way to do it. Yep. I should make the most embarrassing synth module and put like a pressure sensor on one of those booby mouse pads. And it'll be like an effects pad. So you push the booby mouse pad and it does stuff. That'd be the stupidest thing ever. That is such a Twitch project. Where's Uwo? I'll sell him that idea for $1,000. All right. So anyway, we've been reverse engineering Dave's module like months ago. We got pretty far with it, actually. Well, we got far with 2 sections of it. Not in chat, can't tag him. You don't do that when I mention other people. It's okay. He might pop in later. He does that kind of thing. Still have a bottle of UV blocking ink. What is that? Huh. Oh, transparencies for UV dry film exposure. That's a weird one. No, I mean, basically what I'd be doing with the UV tank is you attach UV LEDs to your print head, and then that thing flutters back and forth, and as it's depositing the ink, or either the print head or, something that it's going to contact in like after the print, it'll get to that. And then you can basically just do full color printed graphics on stuff. You just have to get all the alignments right, which is probably the hardest part of the whole thing. But yeah, so we were looking at the circuit, this M303. Now the 303 is a pretty well-known acid house synthesizer. This thing is what's called a voltage-controlled oscillator, and a voltage-controlled oscillator takes a signal in. So Is it on here? VCO out, VCF, VCA, accent, gate, voltage controlled filter, voltage control oscillator, control voltage. They don't call it on this panel. They don't call it that on the panel, but on the panel, it's 1 volt per octave, right? I regret not buying one of those in high school. Right? Father owned an audio store that had a few 303s. I love the 303. You can get them pretty cheap on eBay. You can still get the 303 pretty cheap on eBay. I was gonna get a 505 and use the 505 like MIDI or something like that as a stream controller. So I'd use it to like change scenes and like focus cameras and stuff like that. But the 505 I think is like actually wait, post-pandemic. I haven't looked this up since the pandemic. Let's go to eBay. It's like a 303, but like a 303S or something like that. Oh yeah, it's definitely a cleaning product. Synthesizer, $300. It's not terrible. MC303. Yeah, $200 for an MC303. Not that bad. Yeah. Well, the whole point of the whole point of this, all that garbage, all that crap that's down there with all the stuff sticking out of it, all this fucking shit, that's supposed to eventually allow me to put together something that'll make some music to have in the background. So it's like unidentifiable background music. Join waitlist for an emulator. I think you can find a 303 on a lot of free Roland volume potentiometer, MC303. Jeez. And then the 505 was the one that I actually had through a friend. But the 505 is the slightly larger workstation. Look at all that stuff. It's a legend. It's a legendary synthesizer. And yeah. Yeah, you can probably just get a VST that has it. But there were some legendary things that I probably should have bought back in the day. I don't have that much purchasing power. we spent dumbly, because we were kids, we spent $400 on a MIDI like hub so you could distribute MIDI out to a bunch of stuff. That's not how you do it. You daisy chain everything. You don't have to spend a dime on like a MIDI hub. We were dumb. We were dumb. Anyway, so the M303, the legendary 303 synthesizer, acidlabs.de makes this module for your module synthesizer. They turn the 303 into a VCO. So all the sequencing stuff is somewhere else. All this thing does is create those acidic tones depending on what control voltages you send it in, and it has a 303-esque sounding filter on it, right? I made a MIDI hub for about $5. Yeah, we weren't as resourceful back then, Gonad. And also it was like, you don't need to do that. You just daisy chain everything. So, but yeah, this will make all of those signature beeps and boops of Acid House, and it'll do it as a module on your modular synthesizer. So the sequencer that you like, the filters you like, they're all there for you to play with, along with something that resembles a 303. Acidlabs.de makes this module. I don't know if you can buy it anymore outside of the reseller market. However, Acid Labs also put a lot of work. You thought I was going to bash them, but I'm not. Acid Labs put a lot of work into making modern electronics sound like the old school stuff. You see, the thing is, the 303 was built in an era where there were a lot of ASICs that did their jobs in order to make cool wibbling noises. And there was a lot of analog electronics available. And so things that were necessarily easy to find back then are no longer simple and easy to find. You got to buy them on eBay. DigiKey does not sell this kind of stuff anymore. It's got RISC processing. RISC is good. What's that move? 10 points? God damn it. Guy on eBay is selling the reverse engineered. What? Oh, and you reverse engineered from the pics. Oh, that's kind of awesome. I mean, nowadays for like, if I needed like a MIDI hub, the most expensive part would be all the connectors. And then you could just throw an Arduino at it. And you can throw an Arduino at literally anything these days because every project has already been done on an Arduino. And it's just a matter of Googling it and finding it and mixing it with something else in order to make something unique that you love. No Arduino, just 7400 series logic. Damn. There's the one project that I would like to do, and the reason that I got all of those 7400 series logic chips is like $100 on eBay to get a whole big bunch. 7400 are the big boy logic gate circuits. They all take 5 volts. It's all TTL level signals. ESP32. Yeah, the ESP32 is good. I just have Arduinos sitting around. Nowadays, I'm moving over to like Pico Pis and RP2040s and stuff. These are very fast. But anyway, so the 7400 series chips were famous for, every electrical engineer is going to have, they're going to know what like specific part numbers of logic chips are. Logic chips you can use like a miniature FPGA. I can't believe I'm backwardsly explaining that, but you can put stuff together that's actually very intelligent with logic gates and have it do things that like you would think a microcontroller should be doing. And so there is a drum machine that somebody on Hackaday created that uses only 7400 series logic chips. There's no software. And so I kind of want to put that together at some point. I've got an enclosure that I would really like to use. The fart box is powered by an ESP8266, and we will return to the fart box at some point. What I need to do is set up a Node-RED front end for the whole shop, and then I need to turn the fart box into its own Tasmota style device that we can then trigger using Node-RED flows that ties everything into the same system and allows me to do much more automation in here with ESP8266s. I've got a bunch of those in the cab. Actually, wait, I'm looking at one right. I'm literally looking at one. There's one right here, and I'm just staring at it while saying this. These are like super, super easy to find, super cheap. Yeah, these little, I got some on Wemos boards. I've got some loose ones. Really? Tasmota is just a thing you can flash onto your lights and stuff like that. If it uses an ESP and a couple other different cores, you can flash it onto the lights and stuff. And then there's a Node-RED node that you can put the Tasmota thing on. And then all of your Internet of Things aren't actually phoning home. Oh, you did an 8266 Christmas lights. It's like $100. There's a product from China that you can buy, and that has like an app that you can then use to map all of the lights and have it do like candy cane stuff. And I wanted to do that, but I have a feeling I'd cause car accidents in the neighborhood. WLED, it's basically the same thing but free. Yeah, and then what is it called? Touch Designer as well. That was something that I meant to learn. But apparently all those tools combined, that's a free, easy way to do a lot of very complicated stuff. The thing I wanted to do, and I don't know when I'll be able to do it, there's a Project M is getting milk drop plugins on a Raspberry Pi. And if I can get into some of that stuff, yeah, and maybe I should be doing Touch Designer instead. But the milk drop plugins had a particular look to them, and getting those to map on a low number of LEDs made some really cool patterns out of the whole thing, and I wanted to play with that. 74HC125s. Quad buffer line driver. Oh my God, I think I might have one. WLED is the way to go now, huh? Twinkly LED lights. Yes, there's okay. God, where do I even start with this? People producing these LED. I'm trying to go to the right camera, and I'm getting too distracted by my own brain. People who do like LED stuff for like computers, not very creative. The best you can find is an RGB cycle, right? Or maybe it'll cycle red, everybody's red, then everybody's green, then there's blue. Or maybe it'll just cycle RGB. Without mapping LEDs, it's hard to find stuff that does cool kind of patterns. You want sharp patterns, you want soft patterns. You want background colors, you want foreground colors, right? And so having an animation do that is a really powerful tool when you have a bunch of RGB LEDs that you want to coordinate. And it produces much better looking effects and stuff. So back in the day, I guess I can say that now, back in the day can be yesterday or it can be 5 years ago. I made something for a little washers game that used milk drop and mapped the pixels onto only a couple strips of RGB LED. What that did is that made the impression of a much larger, well, I mean, there was a much larger pattern going on, but it was cool to watch because you had sharp patterns and then you had soft patterns going on that LED, matrix. It was very, very cool looking. It's so simple now. combined into a simple web-based install and app. Combines all the BS from TD and other Arduino projects into one thing. That sounds pretty cool. I should look at that. I wonder if I can run Milk Drop on my staircase. Yeah, if you've got a little bit of an LED mapping, the thing that I came up with, you'll probably want to look at the stuff that FK is talking about, because he's got way better recommendations. But like running Milk Drop for me was, I had to use like a tunneling program, and I had to make a whole processing thing. Ledge. Oh, that's WLED in the middle. Oh, weird. I thought you were just typing something weird. No, it's actually .no. Okay, so last time we did this, we figured out what a couple of the chips were. My notes here, I mean, we had one of the chips, because, okay, AcidLabs.de put a lot of work into making sure that they could use modern electronics in order to sell a module that sounds like an M303 from the days of yore. But what they did, in addition to that, is they actually, they scratched off some of the values of the chips here. And that puts us in a particular bind. You see, the thing AcidLabs.de did, the very German thing that they did, is they used their own proprietary synthesizer plug. The thing about their proprietary synthesizer plug is that it will allow you to daisy chain their products. However, this is still compatible with a modular synthesizer. The thing about a modular synthesizer is you've got a particular number of signals sitting on an IDE plug, and not internal displacement engine. No. IDC. Is it internal displacement connector? Basically, what happens is you have a bunch of little ramps that will move, that will cut the wire out of the way. Insulation. There we go. Thank you. Jeez. Listen, I got a lot of cobwebs in my brain these days. Yeah, insulation displacement connector. What you do is you put this in a vise and squish it. And when you squish it, these little knifey kind of things penetrate the displacement, the insulator, the insulation plastic, and they will contact the metal. And so you drop these things in, you can get a bunch of pins in a very small surface area. They're user-ish friendly, they're people-sized, it's a very human designed. The thing about the Acid Labs plug, typically with these IDC connectors, especially if you've got power on it, yeah, they're like mini punch downs. You're right, yeah, that's exactly the technology. Usually you have, and you can kind of see it modeled in this connector, you have a keyway. Keyway is just a bump, but that bump would prevent you from plugging this thing in backwards. So they give you the specialized connector, and the specialized connector is designed to interface with modular synthesizer power. Modular synthesizer power looks like this. Modular synthesizer pinout. The commonality between all of your modular synthesizer modules this day and age, when things are so complicated and done over and everybody's done everything already, everybody's created their own standard. Why am I looking at fucking Reddit? What the get out of here. No. This has got to be on a better page. Anyway, the point is, like, people have done all kinds of stuff already, right? And there's almost no standardization anymore in your standard modular synthesizer. The whole point of the modular synthesizer was to standardize things. All that we've got left is the panel size and the connector for power. There's also a gate, a control voltage, and a 5-volt connector, but nobody really uses that because you could just make 5 volts and 3 volts off your 12-volt line. So this 10-pin connector is generally pretty standardized. The thing about it is, though, you have a -12 and a +12 with all the grounds in the middle. Kind of would have been nice if this would have been a reversible design. It would have saved me a whole lot of trouble in my life trying to fix all of these synthesizers that my friends seem to keep breaking. Why do they keep breaking the synthesizers? I don't know. Some of the more intelligent module designers are putting, I don't know, just like a diode. Yeah, it's like the connector it should be reversible. In a lot of them, they are. There's one on the Crimes and Ornamentation module. Crimes and Ornamentation, or Ornamentation and Crime, I don't know. They have a full bridge rectifier on the power inputs. So no matter how you plug it in, it will get power. But a lot of people aren't doing that. They
protection diodes are the de facto standard. They would have saved everybody a lot of trouble. This thing doesn't have them. The Acid Labs M303 does not have any diodes on the inputs. Not to mention, they have their own proprietary connector. You can see that is not 10 pins. So what they did is they allowed you to go to a, how many pins is this? 1, 2, 3, 4, 5, 6, 7, 8. So this is the 16-pin interface, right? The thing about the way you plug in the 16-pin interface is you can see that this is not a normal IDC connector. A normal IDC connector looks something like this. It has all your pins there, and then it has your big old keyway. And you can buy big plastic connectors, big plastic pin headers, where you won't be able to plug that thing in backwards unless you really force it in there. This doesn't have that. It has 2 connectors, no labels, no keyways, no markings of any sort. And they give you a connector that is specifically designed, unlike normal IDE connectors, which don't have this feature. This over here, this bit of plastic over here, will block you from plugging this thing in weird. This allows it, because you're supposed to plug this in just like that. Actually, I think that's even wrong. Hold on. I think you're supposed to go just a little bit, supposed to go like down like this. So 1 pin. You got to plug it in like that, I think. We're going to look up how to plug it in. But they have you plugging it in weird because they use a different pin out for their sort of internal, this module to this module kind of connector. And then they don't put any protection on the power input. And so, naturally, Dave messed up one time and blew up the entire module and his house. And a little chunk of Pennsylvania. And a little bit of the Earth's core. Just blew it up. So we don't know what's working in here, and we don't know what's not working in here. So we've done a little bit of reverse engineering on some of the parts of the circuit. Things that look like, well, things that got hot when we powered it up. We had a piece up here get hot when we powered it up. We looked and looked and looked, and we found out that it was a RF part, which replaced an old part, an old LF353. LF353 is a super matched transistor pair. When it's the 90s and you need to make like a sine wave, one way to do it is to have 2 transistors that are alternatively triggering one another, and you do some funky stuff with that, and you can get a sine wave. You get a really nice sine wave. And so instead of that, because that part was no longer available, supermatched transistor pair, everybody moved on to digital stuff, and so they didn't really make them anymore. And so what they found was a quad matched transistor, quadruple, whatever. Anyway, 4 that are super matched as the same damn transistor, right? They had all the same properties. That was the chip that actually went in. So I ordered a couple of those, we put it in, and it still didn't really work. So, and I think I plugged it in wrong, and I might have blown up more of it. We don't talk about that. I'll have stuff with a full bridge on the power intake, especially if it's barrel connector. Really? NES power connector intake? Really? It could take just about anything. That's not... Nintendo's always been really good with power in their internal design. I don't know what they decided on early on, but like their battery management is good. It's like medical style battery management. People pulled Nintendos out of closets after decades, and their batteries work just as fine. So, with somebody with a cell phone battery that's starting to show age, I'm a little jealous. Mega Drive 1 verse 2 has opposite barrel polarity. When you start messing with the polarity of the barrel plugs, you've gotten into some real hedonistic territory. It's like, don't mess with that. There's some things you don't do, and that's reversing positive and negative on a barrel plug. But I guess, you know, it was the 80s. 90s. You just want an NES off a 9-volt battery? When the adapter died. What? That's crazy. Yeah, it's really only the most sadistic. Okay, so we need to figure out how to plug this thing in. So let's look that up real quick, and I can figure it out. And then we can figure out what chip we found at the end of the last stream that I did for this, which was like 2 years ago. What the fuck? Really? Telcom cabinet? Telcom is a bunch of birds' nests that somehow managed to actually function as a phone network. It's kind of amazing that they actually are able to get that stuff to work. What is this called? This is the M303 plug-in. Images. M303 connector. Nope. Acid Labs M303. Now we do have a 303 schematic. We do have the schematic of the 303 itself. We don't know what variations, what they did to the M303 versus just a normal an MC303. There we go. We got two part numbers that are basically the same thing, and one of them denotes the product that we're working on, and the other one is the tabletop edition that has the sequencer and everything in it. See, this is what they're meant to be plugged into, which is this daisy chaining crap, which is ridiculous. Here's the Mod Wiggler forum where they talk about it. So like, there's the right way to plug it in. Stripe on the bottom row of pins. What? Less corrode? Oh, so they're reversing it in order to be like a sacrificial. That's strange. VWs used to be positive voltage to the frame. Voltage doubler input. Use DC. Either the digital bits won't even power up, or the output clips like fury because one of the rails has no voltage. What the hell? That's very strange. 7805. Really? NES had a 7805 in it. That's nice. That's nice of them. So stripe faces down, and we're off by one row, down like this, so that the first active row of the connector is on the bottom active row of the board. Everything was 7805. I've got bins and bins full of 7805s just because that was just what everyone used. So in order to see these lighting up, we could plug them into the cables that I have here. But the last time I tried that, I messed it up and they like blew up. I was hoping we could observe where the heat was. Let's see if we can get the two cables there. We need to do a little hot air soldering, and here's some parts that I ordered a long time ago. So we need to kind of figure out where we were with this. So LM13700 I'm going to look up because that's sort of the main thing about what we were working on. LM13700. I forget who suggested it. It might have been like Pseudomaze. It might have been one of y'all crazy people in my chat, the weird people that I seem to attract, know about stuff like this. Oh wait, no, I think that's the wrong one. Linear diodes and buffering. I think that's what I thought it was, but it was wrong. We have there's an actual chip that I purchased that's an ASIC. It's an audio ASIC for basically doing modular synthesizer style stuff, right? It's like I think like a voltage controlled amplifier or something like that. Yeah, that's sort of the 70s and 80s way of creating power for your TTL circuit. Is you get an AC wave coming in, you put it through a full bridge rectifier, a couple capacitors, and then you just hit it up against the 7805. That'll throw anything that's above its limits into heat. So there were a lot of 9-volt power supplies back in the day. Analog audio synthesis, the LM13700. That might have been the chip. Yeah, and it's maybe it was you, Bridge. I don't know. One of y'all suggested to me that was what that chip was. And it fit perfectly to the pinouts that we were seeing. Here, let me get the notebook out of the way. Like the power was on the right pins, and there were the diodes were on the, everything was correct. I think maybe you should see a specialist if that's what you're doing to get some kicks. Just look at the random data sheets. That's a strange one. I mean, I used to print out data sheets at my school library, And the librarians hated me because I would use like reams of paper to do this. All for stupid projects. Okay, so this is a different chip. I got to figure out why I ordered this and why this is in the Dave synthesizer pile. This National Semiconductor LM3046M. I bought it with a purpose. Was it 3046? Oops. 3045. No, wait, that's 6. 3046. 3046 datasheet product information, blah, 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 blah. Constant current buck LED driver. What the f? This thing's name is Buck. And it likes to play tennis. Why do I have this? Why did I buy this? Why do I have this? LM3406. Did I dyslexize some of it? Where'd the micro go? There it is. 3046. LM3046. Why did I buy an LED driver? Okay, all right, okay. I have a bunch of them. Why do I have these? LM3046. Did I order the wrong part? Because, like, what am I doing with constant current LED drivers? Oh, what? No, that's an M. What is the one? Yeah, they're both LM3046. You're gaslighting me. Oh, 3406. There it is. There's the dyslexizing. 04. This will be TI, but I think they have the same. If it the primary parts of the datasheet are usually like a bunch of different companies will make the same thing, but they'll put a bunch of modifiers. What is this cursed website? Oh, it's DigiKey, huh? Mauser will probably have a front and center. Data chart. Show me. Perfect. Yeah. Oh God, this DigiKey site. There should be a datasheet link in here. Based product number. Multi devices EDA model. Resource type link. Where's my datasheet? It doesn't even tell me like what it does. RF transistor. So this is the quad transistor. This is an RF supermatched quad transistor, which is odd that it's so obsolete, because I think you would be able to at least find a part number for it. And I guess whenever Acid Labs made the M303, this probably wasn't obsolete. So yeah, that's why I have a billion of these things. These are just quad supermatched transistors. They're NPN. Bipolar transistor, BJT, SMD, SOIC 14, 15 volt, 20 volt. They're just jelly bean transistors, but they've been supermatched so that you can make an oscillator with them. There we go, 3406M datasheet. Show me an actual data. Fuck. You sons of bitches. Well, anyway, the point is that it is a quad supermatched transistor. So now we know what that one is. So that's the one that we've already replaced, although I'm going to put this up here because we may want to replace it again, because I kind of screwed up the last time we did this, and I plugged the power in, or I plugged the top and bottom IDC connectors wrong, and stuff kind of heated up a little bit. Weren't you looking for a quad supermatched transistor in the circuit book? I don't think so. I may have mentioned it in passing, but I don't think I was looking for specifically that part. Now, I do have other stuff in this bag. Well, I have a transmitter for my Dexcom. What is this? Why do I only have one? I probably bought a pair of these, and they were probably $10 each. I can't even read the part number. We will have to get it out here into the world, into the big world around. HPA 3046. HPA 3046. HFA. So it's not a P, that was an F. From Renaissance, high frequency transistor array. Wait a sec. Oh, is this an equivalent? So are both of the things in there transistor arrays? Maybe there were multiple part numbers that I was looking at. Yeah, I think that's probably it. So yeah, this one is the 5 supermatch transistors. I think the options were a couple different ones because we don't have a pin number, right? We don't actually have a pin number. That was scratched off. We just have a circuit layout. And so there were 2 options. And I think maybe one that I ordered took way too long to get here, so I ordered a different one. So these are both transistor arrays. I'll pop this one in the same bag. I need to get these into my bins, because otherwise they're just going to be floating around the shop. Hey, what's up, Jackie Codes? 189. That is a lot of people. Welcome to my shop. We're looking at a 303. We're going to try to get it working, although I don't think we're going to succeed today because I've been working on this for a little bit. Ooh, an electronics nerd. You're not welcome here. No, I'm just kidding. Hi. Welcome to my shop. This is where I do stuff on Twitch. We have sort of a big overarching, everybody says overarching. It's overarching. Anyway, whatever. We have a big overarching project on this stream, and that's called Burn the Subs. There's a lot of very busy stuff going on around me. You guys feel free to hang out. We're working on modular synthesizers right now. There's a lot of other stuff that goes on here, and I'm sort of juggling projects. One of the big things that we do around here is called Burn the Subs, and that is that giant plank of wood on my wall hooked up to a little controller on the side. I've been working on that for a long time. There are videos on YouTube. I think you can do BTS command in the chat. What that is it's a Python Raspberry Pi project. It is a laser etching table that is designed to burn the names of people who subscribe to the channel onto a big word cloud of names. And it does it live while I'm streaming. Doesn't work right now. Python's really good because if you actually learn how to code in Python, it's very sort of talky. You can kind of just say, well, okay, for this loop, I want this to happen and do this. And you kind of, you notice you're like, wait, I'm actually, I'm typing at the same speed. Our commands, BTS should be working. I guess Nightbot is probably taking a shit. Oh, there he is. Okay, maybe it doesn't, I don't know why we would lock that one to mods only though. So yeah, anyway, hanging out with Jackie before I came here. She's gonna know I left early to come here. Don't, it's okay. It's okay. Just don't, you don't have to say stuff like that. You don't have to say stuff like that. It's like, you don't want to incur the wrath of another streamer. It's pretty serious. I've still got scars. This pile of crap that actually chat's covering. I've got chats very big on the screen right now because first of all, like, it's funny to have chats really huge, but that means that seeing stuff behind chat is a little bit harder. It's funny because there's very few people in stream these days because we've been working on Burn the Subs and not running Burn the Subs. But with very few people, the chat will eventually kind of free up space on the screen, and you would actually be able to see that behind all of this stuff, there's actually a modular synthesizer that I'm working on. I got a buddy, Julian, who makes music, and he's been after me for more than 20 years to build a synthesizer. What I found out is that in the modular synthesizer community, basically, there are people who have completely burnt out and decided to no longer make the modules that they make. So these modules that sell for hundreds of dollars, they've open sourced. And they've open sourced them as a kind of way to just kind of flip everybody off as they exit. So they just say, fuck all y'all, I'm out of here, y'all are weird. And then you can buy just the circuit boards for these modules. And just the circuit board means that you need to source all the parts, source the code, program it, and tune it. Because they're musical instruments, they need tuning. So I had to figure out how to do all that stuff from an electrical engineer who does a lot of, digital stuff perspective and figure it all out. So there's been many, many streams of me struggling and struggling and struggling to get this stuff working. That was that project, and that's sort of one facet of the stuff we do around here. Since we have so many people, it's like 3 times the amount that I normally see, I will also describe to you this project. This is the steering wheel project. Many, many years ago, let's turn the dial back to 2010, 2011, 2012. When did My Summer Car come out? Wait, I think it was a little bit after that. Whenever My Summer Car came out that year, I was playing My Summer Car with a bunch of friends at a LAN party. We were all playing separate games. It was only one person made it to actually having almost a functional car, and at that moment, they fell into a well of sewage and died. So, in order to play My Summer Car, I was thinking, man, I should really do a force feedback wheel project. The force feedback is, of course, secondary to just a wheel in that game. What I decided to do back before I was even streaming was use the Open Wheel project. The Open Wheel project evolved into a Granite Devices controller, blah, 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 blah. Point is, eventually I had real car parts that I then had to get working digitally in order to become a force feedback wheel. So I've got the steering wheel. You can't really see it at this angle. This is not a good angle. Hold on. Let's go to a different angle. Dying in poop must have sucked. There's the open sewer things that you have to pump. There's way too much going on in the background here. So yeah, this steering wheel and these pedals are car parts that I strapped to my desk. So I've got an actual clutch pedal, I've got an actual brake pedal on the load cell, and the driver's accelerator pedal. I don't know why I said drivers, because I don't think the passenger gets an accelerator in a car, do they? I don't remember. But anyway, the accelerator pedal is already digital. That was a nice, easy one to do. They're all digital nowadays anyway, just for all the control systems in a car. Mercedes steering wheel, it has a bunch of buttons on it. And the cool part about that, I bought it because of paddles, because I didn't want to do a shifter. I ended up doing a shifter. I have an actual gated shifter. This is a 3D printed thing. But the steering wheel itself actually has buttons on it. Problem is, those buttons aren't easy to utilize. I could like take over the buttons, but I wouldn't be able to wire up individual buttons because they've been wired in kind of a matrix. And the matrix is kind of weird. So what I decided to do instead was speak the same language as the wheel, which is called the LIN bus. And we were able to hack the LIN bus. We brute forced the buttons on that wheel. And then I won the My Summer Car Rally, although I haven't uploaded that VOD yet. Is the camera flipped horizontally? No, it's not. The clutch is on the left, the gas is on the right. The pedals are just standing on their face. This thing is actually a floor plate so that my feet don't fatigue from being too steep. So this whole thing, this frame, these are 80/20 rails. This bolts to my chair over here. And then the pedals are this way. Let me turn this around so you guys can actually see what I'm doing. I made the pedals also speak the LIN bus. We had to come up with a packet for it all. But yeah, these go onto my chair like that. And so we have clutch, brake, gas. Ugh, I'm going to trip over that later. Yeah. So the talk today was like, what are we going to do with the modular synthesizer? I would like to do a UV printer for labels on the front panel. And I want to do like, some other stuff with a CNC machine. So do I have the parts to build a CNC machine? It's not CAN. You can look up the LIN bus. LIN bus is the something car consortium. It's a European consortium that came up and said, look, CAN bus sucks. It's really expensive to put in stuff. Mind giving us new chatters a short into I used to reverse engineer IEDs. I'm not too comfortable going into that, but I did do it this stream because what we're doing today is very much reverse engineering a type of bomb. And this bomb was a thing that the company didn't give you enough information on when you're plugging it into power. And so what it is a financial bomb, because if you actually plug this connector in the way you'd think you would, it will blow up your synthesizer. Yeah, they didn't want to spend the expense, so they came up with something like a one-wire protocol in order to communicate between car accessories. So what is the IED thing? It's down in the description, and people find it, and it is there to hook you into the stream and get you to start talking. For 10 years of my life, I worked a little bit south of where I am. Right now, I'm in Philadelphia. There's one person here that can actually contest that. So they're lying. If they say anything else, they're lying. I'm in Philadelphia. Yeah, it worked. Nice. That's what it's there for. For 10 years of my life, I was down in Quantico, Virginia, working for a very well-known, used to live in Philly. Oh, cool. I don't know if I know Atkins Park that well. Oh, right by the train tracks. Is that the, there's a picture of that on the Abandoned subreddit. Anyway, so here's the deal. Need to get hacky with Lin Bus to use the giant pile of Tesla low-voltage batteries I have in the garage. The thing about Lin Bus is it's very reverse engineerable because there's only about like 100 and something or like 250 something addresses that they could possibly have because it's like 3 or 4 bit address. So you can just like, you brute force it. I don't know what the battery will do if you brute force it bad. But anyway, so 10 years of my life out of college, I went down to Quantico, Virginia, and I worked for a household name contractor for a household name 3-letter agency at their technical building. And what we were doing is the whole problem of, well, what the crap is up with all these IEDs? They would basically separate the explosives, ship it back to the United States, FedEx, and then we would get these bags. They would get processed for fingerprints elsewhere. We would get these bags with evidence in them, essentially, but it's foreign evidence, so it doesn't have the same sort of standards of evidence that we have to follow. So we'd put on cotton gloves, we'd get a circuit board on our desk, and we'd have to figure out exactly the right, like how the circuit worked, how it relates to previous circuits we've seen that are similar to it. And, you know, we have to do an RF characterization. We have to do a sequence of events of how the thing goes together and works and functions. And then we have to, of course, relate it to previous, like, oh, this one has a slightly different trace here, and this is an improvement, etc. And then we would publish that to the nebulous intelligence community, and we would have no other dealings with it because everything is so compartmentalized. You know, you don't want to have one person who knows the entire chain of that whole thing. So we would publish them, and then that was that. Sometimes there were high priority things that we had to do, but that's essentially what we did. Did he say what an IED is? It's an improvised explosive device. So it's that's a very large umbrella that catches a lot of different things under itself. And so we saw things that were downright silly, and we saw things that were so insidiously evil that they would curdle your milk. But I did that for like 10 years, and that was 10 years of brutal reverse engineering. Like, you know, you get a device in, you get the multimeter out, and you'd start checking all of the individual traces, and you get those all down on a piece of paper. You would put that into CAD, and you would make a drawing, and then you would rearrange the drawing so that it was very readable. So when it comes to schematics, I have a lot of standards that I follow, and it makes things very easy to follow and read. Sometimes it got to the point where we'd have to make something to help further our analysis, and so we got into some pretty crazy stuff. So I am from napkin to full-blown synthesizer engineer kind of thing here with electronics. Yeah. And then I started doing Twitch because I needed a creative outlet. Well, no, because I got fired. I went to a medical device design job to finally leave that stupid fucking environment of DC. The DC area, you'd go to a party and you'd be like, hey, cool people, man, let's be friends. And they're like, nah, I'm getting out of here soon. And you're like, oh, okay. So you're leaving the DC area to go back home. And then you're like, fuck this place, I'm going back home. And you'd become that person. So that's what everybody was like there. So I came back to Philly, and it was amazing because all my friends are here. And I got a medical device design job for a little while. I was writing for Hackaday. I was doing some stuff like that. And then I got fucking shit canned from that one. And I decided to start streaming on Twitch finally, instead of just, you know, writing. I was like writing a blog that I wanted to maintain, and I never published it. And so I was like, there's no way that I'm going to be able to like get my projects out there unless I start streaming. Because I was like, you know, better than sitting around unemployed. So, and I do this stuff anyway. This focuses me a lot more. Explosives were already removed and disposed of before the control circuits were shipped. Yeah, they ship that stuff separately. Are you drunk? No? What? Why would you say that to somebody? What the fuck? Weird fucking, what the hell? Oh, that's somebody else. Oh, not me. Oh, okay. Sorry, I missed that part. Wait, that didn't... Look at what showed up on my social stream blade. I didn't get the @ on there. What the hell? Hey, what's up, Frumius? Frumius, there we go. Yeah, look at this. It looks like you were just calling me out. I'm like, I'm not drunk. The social stream blade, it's censoring. I gotta be careful about that. Yeah. I think I can make those show up in social stream blade. I just haven't bothered to do it yet. Because you gotta like manipulate the URL that you go to. I got a whole bunch of crap going on with streaming both to YouTube and Twitch at the same time. What have I missed here? There's like a 1 on there. Is that you're invited to see the new Twitch partner Discord? I'm already on it. What are you, huh? Oh, really? Yeah, we've dealt with the Twitch API for Burn the Subs, and it's a mess. That Twitch API is a mess. I don't know, is it a new one, or is it the old one and they're just advertising it to us again? Because Twitch always does this weird stuff. Yeah, but we dealt with the Twitch API for this thing. I used to have, and I don't have it anymore. I still have it. Still have it, but we have a fart box. And the fart box isn't working right now, but this is a channel point fart noise maker. Oh yeah, there was, I have it like perma-muted on Discord. I probably should leave it too. I haven't done anything in there. They just announce something every now and then. Really, they change it without warning. The one thing we don't get, and I don't understand this, is because when somebody redeems channel points on this thing, it plays a random fart noise, right? But the API that comes in from channel points, there is an individual hexadecimal, alphanumeric transaction ID, right? Here's this transaction ID. We've done our thing. And I'm like, cool, that's cool. Let's just store that transaction ID because there's fucky stuff that people can do with the Twitch API. People can announce their subs 3 times in a row. And I don't mean by upping their sub level. They can announce a sub that is lingering. They can then subscribe and announce, and then somehow, through some hacky shit, they can announce a sub again. So we have this whole gauntlet of conditionals that the name has to get through in our database in order for it to actually put the thing up on the board. And all of that would be usurped with like 1 line of code if they just gave us a transaction ID associated with the financial exchange. Like, somebody paid $5, it is connected to this number. Oh, somebody's announcing again, it is connected to this number. Just keep that, because that would be a thing that I could use to keep people from cheating the system. And we encourage cheating the system on this channel, because if you cheat the system, I'll code it out of Burn the Subs, and then we can have it so that Burn the Subs is that much more effective, right? That was something that like I had to kind of like beat into my crowd. It's like, please do the stupid shit to break everything. I want you to do that. Give us 5.0 back. Kraken was the best. I think I was using Kraken. I think the old board, it was like 2 years ago. I've been working on the new board, and we've been doing a lot of Fusion 360 design in order to 3D print like brackets and stuff like that in order to hang stuff up on my wall. There's still some hardware stuff that I want to do. One of the big things that we just figured out is using ultraviolet epoxy to seal a PETG print. And I didn't up the flow rate on the PETG. I probably should have done that because I saw another YouTuber made like a really cool like water cloud kind of chamber thing. Basically used India ink to make little clouds of stuff and display a laminar flow, and then took that into a filter in order to filter back out the India ink and have fresh water that they could inject into one end of the tube. So they took the 2 elements mixing and displayed it, and then separated them again and ran them back out through. Awesome project. But the end caps of a glass tube were printed in PETG. I was like, wait a minute, what the fuck? Like, that's something that I tried to achieve. We tried like sintering our prints. We tried all kinds of stuff to seal them up, and nothing worked. We used ultraviolet epoxy on the inner surface. Solder mask. I don't actually have any solder mask. The UV epoxy is what I would use instead of solder mask. I don't have that stuff. I think that stuff is pretty harsh chemical, but maybe I should get some. Once wrote a song while working on a Chevy. It's called Brackets on Brackets. Sounds Chevy-like. I know Chevy's okay. Basically the same thing. The UV epoxy, I'm afraid that if the PETG and the UV epoxy are heating up and cooling down in the process of a, 4-watt blue laser, because this is an exposed, I didn't mention that. This is an exposed bright blue laser, and it draws all of the names. So there's a theatrical element to it where you get to see a cool laser beam and a little bit of smoke. My worry about that is that those two are heating up and cooling down. And if the UV epoxy plastic doesn't have that kind of 3% shrinkage factor to it, those are moving at different rates and they will separate out. If that shell is complete enough, that'll be okay. But if it's not, that's a water ingress or outgress or whatever you want to call it. Water's going to get out. What power? I wanted it to be 1.2 watts. We don't need more than that at the speed that this thing goes. But it's impossible to, yes, one singular piece of ham. But it's impossible to find due to DLP and telecom technology lower power blue lasers. It's all super duper balls to the wall, ultra high power laserage. So the ones that I have, I think are a solid 2 watts, which is too much. That's dangerous. Then again, I'm in here, I'm facing you guys. Now the other day we took a glass filled with cloudy white water. I bought one of those like EKWB bottles for like water cooling. And I can tell you, don't use the cloudy stuff. It's stupid. Just use water. But anyway, the cloudy stuff I had in a big container, and I had it sitting out on the desk, and we had the blue laser running full ham right into it, and it was making a lot of splash lights. Blue lasers create a lot of ultraviolet light. So by the end of the day, when I was done streaming, I stopped streaming, and I felt like I had been standing on the beach for a couple hours. I was like, well, I can really feel that in my skin. I shouldn't do that again. So anyway, I'm facing the opposite side. No, it wasn't milk. It was EKWB water cooling fluid. That's like this. It looks like cum. Let's just be honest. But yeah, just like welding burn, exactly. All the UV component of a spark, similar to the UV component of the laser, is going to be a much lesser ultraviolet light, but it still felt like I'd been standing in the sun, even though my beard and I get itchy from blue laser. When Burn the Subs is running, I'm facing the opposite direction. I'm not actually looking at it. I'll move the camera over to where it's going to burn, and then I'll come back over here and sit down. And so I'm not stressing out my eyes by having an exposed laser beam. I could probably get an orange plastic tube and put that on the beam path, but well, yeah, spark is going to contain a lot of different frequencies. So we were doing something a little bit more boring today, and then I got raided by the entire population of a small city state. We were reverse engineering this 303, and I was just kind of getting into it when you guys came in here and ruined my day. This 303 belonged to a buddy of mine, Dave and Julian. They make music. I can link you guys to them if you feel like a little psytrancey stuff. Julian, enter. So his link tree is there. Zelikovic is what he's producing under right now. He got into modular synthesizers, like in a serious way. And he and his buddy Dave have been buying all kinds of cool modules. So my first blush with this stuff was actually repairing an Erica Synths module. Well, what do you think? How do you think I got the reverse engineering job? You can't listen, you can't spell engineer without the backwards near without engineer backwards. You can't forwards without backwards. Modular is a drug. No, Dave's not. Dave's gone, man. He's gone. He's gone. There's we have other Dave. We have Dave at home. Okay, so this thing has been sitting for months, nigh on maybe a year. The thing about acidlabs.de is you're supposed to plug in, because modular synthesizers, in spite of all the stuff falling out of standardization, the sort of principle behind modular synthesizer components is that you have standardizations, and the standardizations allow you to have custom things that go together to make what's essentially a synthesizer. So in the case of the M303, we have what powered the legendary MC303 sequencer and synthesizer, only without the sequencer part. So we have the voltage controlled. In this case, we have control voltages, you have audio signals. Those are not standard outside of modular synthesizers. If I plug my audio out into a speaker, it's going to almost blow up the speaker. You got to be careful about that. There's much higher voltages in a modular synthesizer because you want clean signals throughout the whole thing. So the higher voltages are much cleaner than a consumer voltage, because consumer products are plagued by portability. Portability means lower voltage, lower power consumption. Modular synthesizers, pardon my burping, is a standardization for musical stuff, and they decided to run off of a plus minus 12 volt rail because it's easy. Plus minus 12 volts, most of your what are called op amps are going to run on those voltages. And so you have positive and negative AC voltages. You can do all kinds of equations much more easily with sort of the big 12, right? You got 24, what you have is a 15 volt power supply coming in, and then you regulate it down to negative 12, and then you also regulate it to positive 12. There is technically 5 volts in a synthesizer, but nobody really uses it anymore because it's easy enough to put your own voltage regulator in your circuit. I know, look, it sounds like a lot of gobbledygook, and as soon as you actually get into like electrical engineering and stuff like that, it'll click. Because you'll be like, oh, plus and minus 12 volts, like what is that? That doesn't make any sense to me. And then you do your first, like baby's first op amp project, and you're like, oh, this makes it so much easier. Voltages are just potentials, so everything is related to where you're measuring it from. If you have 0 voltages and you call that a ground, anything above that in the positive voltages, of course, has a higher potential. Anything below that has a lower potential, and so stuff will flow from lower to higher potentials. And if you talk to Veritasium, he'll confuse the shit out of you and say it's actually just charge potentials on the outsides of lines. But you don't need to talk like that. Yeah, no, listen, I have a certain like segment of people running around on the channel. Like, okay, when you enter like a new thing and you know a little bit about like what they're talking about, you definitely want to be heard. You want to make sure that you're known for like the stuff you know. And I've struggled with this before too. You know, you enter a chat and you're like, I know about this. I need to say something. I have the benefit of this coming out of, you know, like, I don't have any delays. It originates here. So I am moving through the conversation and explaining things that I've explained many times. I will get to it before a lot of the people who are trying to chime in and seem like they're an expert on something. And I say seem, they are, you know, some people know a lot more about this stuff than I do. And I try to be open to that, and I try not to be too snippy about it, but I'm from PA. I'm going to get snippy about people. People are like, that's not what I meant a lot of the time. And, you know, whatever. I do it because I need to keep the conversation going and I need to keep things fun. But don't take anything too personally here. And I'll try not to either. There's a lot of information to relay here. So yeah, modular synthesizers are just a way to, and you know, I'm explaining it on an engineering level. On a music production level, you basically just have a couple different signals that you plug in with headphone plugs. So you have control voltages, you have 1 volt per octave voltages, you have audio voltages, right? So you take your audio signal, you put that into a filter. But how do the filter know to twist the knob like that? Well, then you take an oscillator that's twisting up and down in terms of the voltage level, and you plug that into a control voltage input, and then it twists the knob for you. So that's essentially what a modular synthesizer is. This is a voltage-controlled oscillator and also a voltage-controlled filter. VCO, VCF. The VCO, you put your 1 volt per note and you get and you're like, oh, okay, that's enough of that. Or depending on if it's like a square wave or something like that, right? So you got this really obnoxious like coming out of this thing. What you want to do is then put that through a filter so that it can sound like and it's like, wow, that's great music. I hope I displayed that properly with my onomatopoeia. That's not onomatopoeia. What is that called? Anyway, I really want to understand what you meant. That's okay. When it says plus 12 volts, it means from the default, there's 12 more potential. What is potential? These are good questions. I don't know if I want to do this on like paper or what. So you can see here, you can see the plug for my power supply. What the fuck does he mean? There's so much stuff on camera. Look at all that, like, what is all that stuff? Voltage plug from power, there's like 60 plugs in this. Okay, this Agilent power supply is what I use to power up the synthesizer modules. And I have it plugged in over here. What's over here is plus, common, minus. There's 24 volts across these two plugs, but on these two there's 12. There's also 12 on these two. Want to sample all those noises. All right, pervert. So there's from this reference point to this reference point, you drop 12 volts. So if you reverse your plugs, you can think of that as positive 12. And if you reverse the plugs on the other two, that can be negative 12. So it's really just what you're doing with the voltages that are coming in. It doesn't matter where your reference point is. But what we do is we commonly refer to ground as being in between the two AC voltages. And the same thing happens like, wait, but if my headphones have a wave going into it, is that going positive and negative? Well, not necessarily, because in the consumer electronics, if you have only positive voltages, your wave would look like this, right? But your electronics can't deal with this because they don't see it, because they're referenced from here to here, which would be like 0 to 5 volts. So what you do is instead, you put it on an offset voltage. So if you have half of your voltage there, then your wave still fits within your 0 to 5 volt limit, and you can have a portable device that only takes DC power in. You just reference it from a different, what is this? Ralph 124C41. I feel like I'm talking to a robot when I say that, which is kind of cool. Thank you for the 9 months. That's a large number of months. What makes potential drop to minus 12 versus rise to plus 12? Well, that's all in transistors and stuff like that, right? So if I have, and actually what I did with mine was I took modules. Modules are the easiest way to do it. The way that they're creating negative 12 volts is probably through some form of magic. But apparently with a power supply, I'm looking for a power supply module all the way over here. Because you can do all kinds of weird trickery in electronics in order to create larger potentials than actually exist. In order to do something like raise the amount of power into a circuit, you can switch it through a coil. And I have these modules, like this thing right here will produce positive and negative 12 volts within the power module. That's how we do it, because we don't want to make a circuit from scratch that does all this stuff. If you have to make a higher voltage and you have a lower voltage, you switch it through a coil. And a coil is essentially what I just said. It's a coil, right? So you have a bunch of wire that's coiled up, and when you put power through it, it will create a magnetic field around that coil. If you cut off the power to that coil, that magnetic field disperses, right? And it drops suddenly. A coil, in the presence of a changing magnetic field, produces current. And so what'll happen is, if you have a certain amount of voltage on that coil and you cut the power suddenly, you get a huge, actually it's a huge negative spike. You get a huge negative spike in power until it returns to zeros. Let's just say here's your number line. You get this huge negative spike. What you can do is you can put a capacitor on that negative spike and you can store it. And if you store that higher potential, that higher voltage, you can then distribute it and regulate it out as a higher voltage. So that would be a boost converter. There's a lot of weird stuff in electronics, and this is just one of the spiels that this is not even related to modular synthesizers, it's just how to change electric potentials. There's all kinds of little tricksy little ways like this to do it. It's cool stuff when you have a very basic explanation. And then what was I going to say? I had another spiel. Oh, if you're dealing with relays and you're switching a relay, you want to make sure, in order to not expose your transistor to that giant negative spike, you want to make sure that there is a diode facing the opposite direction a diode normally would across that coil, so that when that negative spike comes in, you can have it travel. What direction is this even in? Is that it? That's not even a diode. Wait a minute, I can turn it into one. There it is. You want to make sure that the diode is actually throwing that giant negative spike through the coil and not your transistor. My high school electronics teacher taught us this concept by connecting a bench power supply to a spool of wire and making us disconnect it with our bare hands. They were built differently back then, huh? But yeah, so we're playing around with this kind of stuff. Reverse engineering takes a little bit of know-how about how things work in the first place. But your first task when reverse engineering something, well, we're fixing something. So in first task in fixing something is identifying the problem area. In this case, it's everything. But the second task is to look up the identity of the integrated circuits that make up your thing. You know, you can, the forest in the trees, you start with the forest. What is the purpose of this forest? It's for woodchucks or some shit like that. So the purpose of this thing is to make output voltages depending on control voltage inputs and knob inputs. It's not doing that. Why? Plug it in, put power to it, use the super duper advantage that I have in that I have a thermal imager to see minor differences in heat. So you can see what's working. The work in electronics is done by heat. Heat damages electronics because hot stuff does not conduct very well. And if something doesn't conduct very well, it gets hot. And so it's this cascade of heat and conductance. And then you get explosions when the materials of the thing that's getting hot gas out at that temperature. So you have different materials that are all sandwiched in this epoxy package. And if some of those materials get to the point where they want to release gas and they can't pass gas, the substrate that it's contained in, getting hotter and hotter and weaker, will pop off sometimes. So the problem with this is that acidlabs.de, these German psychos, made a very nice little module here that mimics the function of the MC303, just without a sequencer. This is just a module that you could plug into your modular synthesizer. Modular synthesizer takes power in a particular flavor, and as long as you follow the markings on the connector and plug it in just right, because there's only one, there's only like 17 different ways to plug this thing in, but as long as you don't get it wrong, your module should probably not explode. Turns out the way to do it is with the stripe facing down, and you're off 2 pins so that the first row of pins is the first row of pins on there. They give you a special connector that can plug in offset. And if you plug it in normal, it blows up. Ask me how I know. So yeah, in addition to that, they have done the reprehensible in my mind, because I'm a reverse engineer. They have sanded off. Hold on, let me stabilize this image real quick. Something's in the way of my light. Son of a... Okay. They've sanded off, they've filed off the markings on these chips. Now, it was only by the grace of my audience knowing this kind of stuff that helped us find the identity of some of these chips. We did a little bit of reverse engineering up here on, I think it might be this one, that was sanded off, but now we actually know the identity of it. And it is a 5, I thought it was 4. Now it's a 5 transistor super matched transistor pair. Transistors aren't necessarily switching elements. You can have, the transistors all have curves to them. They used to be used as amplifiers. If you need a really cheap amplifier, you can use a transistor. If you need a switch in digital electronics, you can also use a transistor because they're able to switch very quickly. But one of the things they do, one of the things they do, damn it, I did it again. I keep doo-dooing all over the place. One of the things they do, is to actually slowly switch over the current, and it's all physics. And so you can use it as an amplifier for like audio style signal, analog signals. They don't do that so much anymore because transistors are sort of hard to control. There's a lot of variation from transistor to transistor. You used to have a device in your electronics lab that you would plug a transistor into, and it would characterize it. It would give you the curves of the transistor and how it would do the business of switching over and allowing current to flow through. Transistors, just 3 blocks of silicon that you put together, and then you can put a potential charge in the middle block, and it'll allow current to flow through the whole thing in a direction. So there's a lot more physics to that. You'll have to look that up on your own. Many people have explained transistors. I explain them all the time because it's a fun little explanation to go through, but I've been gibbering for like 20 minutes and we haven't done anything since the raid, which is awesome. Thank you very much for sticking around, all y'all. Blowing up TL074s because I inverted the plus minus 12 in KCAD and KiCad. Oh, that's a tough one. I actually put the power when I designed the VCO that we were building based on a Hajiwo design. I put the power plug upside down in the schematic, so I didn't have any idea that I was doing things wrong until this thing didn't power up. And it didn't power up because I put a couple diodes on the input. Unlike the people at Acid Labs who are totally fine. They're totally fine with you plugging this thing in any which way you can figure out, because if it blows up, maybe that's another sale. They didn't put 2 sub-dollar value diodes in the voltage path. I did. I plugged this thing in wrong and it didn't explode. Fuckers. Anyway, so we're dealing with all the stuff that Acid Labs has left for us to do. We identified one of the chips. The main players in this thing have been scratched out, and we're not quite sure what the values of these things are. Modular, that's just random words. I was going to write engineer backwards in a silly joke, but there's something too close to... Oh. Well, there's re in it. I actually have a lenticular sticker on my other oscilloscope that does engineer forwards and backwards. I think you need to be totally crazy with it. The one thing we don't allow is the acronyms for resistor color bands here, because those get spicy and it's stupid. Not only do they get spicy, but they're not like, it's not funny. It's just tiring. What's up, CS Strachan? Okay, so what we're looking at over here, I have no idea actually what we're looking at over here. I've got a couple chips and bags that I was hoping to find the identity of, because at the end of the last time we were working on this, we figured out a lot of what the elements of the circuit were doing. I guess I meant to do this earlier and I keep ADHDing my way around the discussion, is when you're reverse engineering something, you obviously start with, well, what does this thing do? How does this thing function, right? And your goal is, well, if you're doing the reverse engineering on the level that I am, your goal is to have a schematic that goes from the upper left-hand corner to the bottom right in terms of functionality, because that will display to other engineers what's going on. That's how you go over a page of a schematic. You go upper right, left, scan down, and you just kind of move through it that way. If you know, there's a lot of schematics that don't do that. There's a lot of different ways to display schematics. Some people do rail-to-rail stuff. I like the story from one end to the other. So inputs on the left, outputs to the right, and then everything moves down to where your outputs are, right? And then power, of course, can go any which place that you want it to. That's sort of the general. Yeah, I don't like ladder rails. I don't like ladder rails. They remind me of like telecom or factory equipment, stuff like that. Like they'll use those ladder notology where they have the thing on the top and the bottom. Left to right, input to output. Is that what I said? Did I say it the opposite way? Because I go, I'm showing it as if I was looking at a piece of paper. If you guys are looking at it the way that I am, it's from upper left to lower right. If I explained it any other way, you can ignore it. You're going like this across the page with the schematic. The same way you would read a page, right? The IR camera, there's some really cool tricks with the IR camera that I can show, because I have a giant block of aluminum sitting over here. Do I? Wait a minute. Oh, there it is. Cool thing about long wave infrared. Did I say right to left? God damn it. Yeah, no, I meant it the other way around. Thank you for paying attention. The thing is, like, if you can't necessarily see a reflected image on a block of aluminum, the long wave infrared still has a chance to give you, where is that? To give you a coherent image. Look at that. So you can see my glasses in thermal imaging look like sunglasses, so I automatically look really cool. But you can see, and by the way, this dot of heat is actually the thermal imager. It gets hot. Ironically, it gets hot when it functions. It gets a little bit warm. But yeah, you can do cool tricks like that where you've got an object that you certainly cannot see a reflection in, but you can still see an image. That's because this thing is colder. It's colder than the long wave infrared that's hitting it, and so it is showing the reflection of that long wave infrared instead of its own heat. And that happens with, hold on, I'm putting this away so it doesn't fall on the floor and break somebody's toe. With anything metal that I have in this shop, that'll happen. So this thing has a nice matte coating on it. But if I have exposed pieces of a circuit board, you'll see little dots of heat on the exposed pieces of the circuit board because the lights that I have, those are hot and they show up and stuff. It's like this, for instance. Yeah, glass does that too. I have IR cameras to see reflected heat. There's some European companies are coming up with cheaper, higher resolution, long wave infrared imagers. There's something to look out for. Because this we bought a long time ago. Where's that reflection of the lights? Usually you'll see like sparkly reflection in the vias of this thing. All right, the thermal camera is really good for when we do soldering and stuff too. It's quite a useful little tool. Yeah, you don't think heat bounces off of stuff, but it ruins a lot of the visuals here when we're trying to look at the temperatures of stuff, because it'll display my desk lights rather than an actual thermal image. Or people will identify something like a tool that I've put down on the desk, and they'll be like, "Why is that so hot?" It's like, it's not. It's just reflecting. All right, so Dave's synthesizer. I wanted to get a little bit done on this because we're going to be doing Burn the Subs on Thursday, and then Friday we're going to go back to the big book of circuits. We're not going to do the fish noise. I'm a little bit annoyed that we couldn't make the fish noise, but there should be other stuff that we're able to make in that big circuits book. Chinese sell high FPS. Yeah, we have ITAR. It's called ITAR, International Trade and Regulation, and ITAR does not want you to make a heat-seeking missile. Believe it or not, we discourage that sort of thing. But boy, would it not be hard to make a heat-seeking... Well, the thing is, the frame rates are limited. It's kind of the same thing with GPS. GPS does not travel over a certain speed. It'll shut down. What do we have here? We have a completely unidentifiable chip that's too small to see the text on. Move my hand to the other side so that we can actually get some light on it. National Semiconductor. Oh, is this is the same one as before? The 13700? LM13700. Okay, so that we looked up earlier, and that one is this chip. Dual operational transconductance amplifier with linearizing diodes and buffers. Bother, how in the hell were you able to find this thing? Of all chips to find by reverse engineering. By the way, you know, schematics are runes. We're casting spells. Walk around with a large sheet of glass. Yeah, I mean, you know, yeah, all these things are very strange. This is I guess, like an audio style. Is it an audio style amplifier with bias and stuff like that? What we ended up doing is figuring out what the circuit around this thing was doing. And it turned out, and oftentimes it does, it turns out very much like the example circuits in the datasheet. Datasheets have a particular structure to them. Sometimes datasheets are completely discombobulated. Hey, Pyros, what's up? Sometimes datasheets are completely disorganized and you don't know what's where. They generally start off with an introduction. They give you the sales pitch. Why would I buy your chip? Then what they should do, well, aside from pinouts are always nice, is the second one. But then going into immediately your maximum characteristics. So what does it take to blow this thing up? How is it going to function? Here's a little bit more about pinout, and then we do absolute maximum ratings, because these are the typical questions that an engineer would come in here with. Well, I want to run your chip. What does it do? I want to run your chip. What do I hook it up? Like, how do I hook it up? I want to run your chip. How do I blow it up? So those are essentially the three beginning questions. And then we get into some of the more eclectic characteristics of the thing and charts and whatnot, things that we can ignore, like the internal transistor structure of the block diagram of the thing. I don't care about this. The people that do care about this have such glowy brains that you can just let them go ahead and ascend into a state of pure energy. How do I use it? How do I kill it? So yeah, then you have example circuits. Typical application. So you'd have a 1 kilo ohm potentiometer, you'd have blah, 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 blah. And then that's essentially what you would hook up to your circuit. So we were looking around at where power comes into the chip, which is somewhat standardized in some cases, and it can actually tell you a little bit about what the chip is that you're using. For us, we had kind of a unique circumstance here. Power was coming in on pin 11 and pin 6, right? What is that all about? Pin 11 and pin 6. Usually you'd get, like, especially in 7400 series and like your TTL logic and some more modern stuff, microcontrollers, things like that, you get like pin 8 and pin 16. The corners would be where your pins are coming in. Pin 1 and the last one, usually it's 16 and 8 or 4 and 8. You know, power in on the corners. That's usually how they do it. But in this case, they went with symmetry, I guess, and they took negative voltage in pin 6 and pin 11. Microcontrollers sometimes can do that. You get microcontrollers where they put the power in the middle. So we had a little bit to go on at that point, and I couldn't really figure it out from there. But one person who had been watching for the stream knew a little bit about synthesizer designs and was familiar with this chip. And so they just suggested this out of the blue. And when I looked it up, it seemed to hold water. So in this circuit, if I get my multimeter out, fortunately, I can't use the super duper cool oscilloscope to display this. I'm going to put this chip over to the side because I think we're going to put the new one in and see if this thing works. I'm caught in my light. Give me this. Okay, there. Whoa, okay, my light just moved on its own. I thought I was going to fall over and make a huge crash. Well, the thing is, like, yeah, that's true. Some microcontrollers are insane. They just do whatever they want. But the stuff that we're familiar with does the corners. And this is a not so microcontroller-y design, so I can assume, and I might make an ass of me, but if I assume that they're not using microcontrollers in this. So negative voltage coming in on that pin there, we need to follow it, and we're going to follow it all the way to the chip. So we're just going to start with our input power. Power is kind of a good place to start with a lot of reverse engineering because it'll give you an idea of what everybody's doing. So minus power is coming in right here. I need a pointing device, and I need this to get a little closer. Negative power coming in here. It buses out from its buddy over there. So we got the bus right between these two things. That's our negative voltage. So negative is, oh wait, am I upside down? This frickin' board. This frickin' board. No, okay, so we're here with negative V in. Negative power coming up and down, two different paths. One path brings it up. We go directly into a chip. What have I said about doing this? This is incredible. I would love to install diodes for Dave. Diodes for Dave sounds like a charity, but diodes for Dave so he doesn't blow this thing up again. He didn't want me to do that, though. That would actually be kind of funny if they threw it in and it looked like an op amp. So we have a capacitor on one of them, and then we have it branching out with a via. Vias are a way to get your circuit signal from one side of the board to the other. You can tell if a PCB is 4 layers if they have a fully circular via that's not connected to anything. So if you can see on the outside layer they did that, then they're connecting it to some kind of an internal layer. But in this case, and sometimes there are blind vias, and those are just evil. Blind vias are where you actually coat over the via and you can no longer see it anymore. That's evil. Those are expensive to do, though. Diodes for Dave, save a device. Save a device, call now. So a via is essentially like a rivet. It's a rivet that goes through your circuit board, and they're plated. Sometimes people actually insert a little metal tube into the via. But in the sense of most circuit board printing these days, they're going to be plated through some kind of a plating process that connects your vias through the hole. What a via can also do is, in the case of a pin, like a soldered pin via, that creates a very strong connection to the board. There is, in fact, a soldered pad on both sides, so it's like a solder rivet that's holding your pin in place. They're extremely strong. Well, yeah, it's like a hole with a little, like a copper tube. Sometimes, like, it'll be, I don't know what, plating, I guess they would use copper, wouldn't they? But then they would put, like, something over it. So, negative over here, it buses over to here. There it goes to a giant capacitor. If we look in on that via on the other side, oh God, which one is it? Coming in from this cap, it would probably, that might be a via. So it'd be this little cluster, doot, doot, doot. And so we're gonna go doot, doot, doot. So this is the negative, and it's coming around and it's going to the other, come back here. So supposedly this is our negative coming up and around like that. I can check that. I can use the multimeter and I can use it on ohms and not the beep setting. So many people would use the beep setting. Oh my God. Beep. Beep prepared. Negative here, one probe. And then the other probe up on this thing. Now, the reason that you don't use beep is very convenient. You don't have to look at your multimeter. The thing is, so much more stuff can go on in your circuit. Using ohms, using the beep is purposely locking yourself off to not getting a bunch of information that you could use. If you happen to get close to what you're tapping and you see something like a nice big even value of a resistor, you wouldn't see that with a beep function. You wouldn't download a car. And also, your coworkers don't want to strangle you and leave you in a dumpster, like I had to with so many technicians in my day. So anyway, yeah, negative value is going all the way over to this header here. We confirmed it by getting a 0.6 ohm signal on it. The other thing is I use sharp high voltage probes. These are high voltage probes because they give you this long standoff between what you're poking, and your actual lead cup. The thing is, though, I don't care about that. I just care about the fact that this thing almost constantly draws blood when I poke myself with it. The advantage of that is because if I'm testing a trace and I don't have a good place to face space, lace, mace, anyway, if I don't have a good way of getting a tap on this, I can actually just put this up against the solder mask and press it in really hard, and it will make electrical contact. The beep is for tracing of wires in a loom. The beep is for lying to you and annoying your coworkers. I'm an individual who's burping. I have had diabetes for 31 years. I can't believe that number, but it's true. I've had 31 years of diabetes under my belt. All the diabetes equipment beeps, and it's all got the same beep. It's all got the same beep, and that beep is a piezoelectric beep. So if I hear a beep, something important's happening, and I have to pay attention to it. Only recently, with this third-party crap, the programs that I can use in order to loop my pump and do all that stuff, have I been able to turn off a majority of the burps, of the beeps. So I've turned off a majority of the beeps, and it's just so nice. Pre-diabetes, keto, lost 100. I have a different diabetes than that. It's actually a totally different one. What is it? Oh, the grandma. He was an Olympian, you know. The My Summer Car grandma. No, the beeping is so annoying, though. It's dictated my life for so many years. And it's just nice to finally be done with it. So you guys have seen, I have like a visceral reaction to things that beep. And I've way in the past, I don't think anybody's around that's seen me do that, but I have destroyed buzzers with pliers before on electronics. I can't stand it. There's nothing that's so important that it garners that kind of a beep. I need a glass of water because my voice is starting to get, I've been gibbering for like 20 minutes. Actually, I said the raid was 20 minutes ago. I don't know when the raid was. No, we're not modding a diabetes device. No. I went to Android Auto Pancreas system, and I've had a great time with it until there was a software update. And I was looping, having a great time, doing my thing. My pancreas was almost automated completely. I only had to butt in every now and then when I had insider information about why my glucose levels sucked. And then an update came along, and because the person who makes the AAPS software is a raging asshole, I don't know about raging, but they're an asshole, they decided in a way that only a programmer could decide, hey, CosmoQuestX, in a way that only a programmer could decide that if you don't update your software, it would lock you out of one of the primary features of the pump. So they would lock you out from looping. It would still turn the pump off if you went low, but that means hyperglycemia. And that happened at midnight. So if it happened overnight, I could have gone into diabetic ketoacidosis. Yay! CosmoQuestX, hey, welcome to the fray. Space raid. I don't want to be raided from space. How's everybody doing? Does Twitch do? Now it's probably all in the ground is where all of our. I'm wondering if I'm going through space right now. Do you think my signal is going through space? Probably not, unless somebody's on Starlink. I don't think we're cool enough. What's going on up in the great void? Space raid sounds contagious. I got space raids. Yeah. That sounds horrible. I got a space heater in my space truck. You guys should check out CosmoQuestX. They do like space news and stuff like that, and they're part of the knowledge fellowship of smart boys. Well, I shouldn't say smart boys. I mean boys like a universal thing. Smarty pants is probably better. Although they might not be wearing pants all the time, so I can't really make any guarantees on that front. Yeah, I wonder how much space my signal goes through. How long have I been exposed? Disabling a feature requiring a firmware update sounds like it was a vulnerability bug that was a feature. Whatever it was a turbo fucking asshole move to do, because I was playing Fallout 4 and I look at my pump and I'm like, wait, I haven't heard any clicking noise. And so I look at my phone and my phone is like, your version has expired. I'm like, yeah, great. The thing is, previous versions of this software told you that it would lock you out of a feature. I got pants but no shirt. I think that's, we don't have that kind of policy in shirt and shoes and stuff. You're fine. So, middle of the night, the warning that I got was that my version was going to expire. Nothing more, right? Previous versions said looping would be disabled, which is still a turbo asshole move, but at least they're letting you know. So I didn't know, and so I didn't do anything to upgrade before that. So 3 o'clock in the morning, I look at my pump and I'm like, my glucose level's like, I feel weird. Glucose level's kind of strange. I happen to be awake. If I wasn't awake, that could have been a real situation. I had to update the software on the pump. So I had to open up Android Studio. I had to update things to the latest version. Apparently, and I forget what it was called, I remembered it at the time, there's some weird Java thing that you shouldn't update. Gradle, the Grable, yeah. The Grable label. So you're not supposed to update the Gradle, but I updated the Gradle because I was updating stuff. And I said at the time, it's like not an angel and a devil, just some two assholes popped up on my shoulder, and one of them went, well, you always have to get up to the latest, because that's what you do in programming, of course. You know this computer stuff, like the Raspberry Pi. You always update the Raspberry Pi. It's, how could you? You're so naive. And then on the other shoulder, it went, oh my God, you updated? How stupid. How stupid of you to update. Everybody knows you're not supposed to update because it simply works. It's like OBS. You don't need the update. The update is stupid. And so I'm like, well, the one that says to update probably has, that one probably holds water. So I updated, and then all this stuff went wrong. And it turns out I had to go into something and like, I had to downgrade, and then I had to tell it to use the previous one, not the current one, because there was something about loading code from GitHub. It would automatically update the text of the code to your latest Gradle, and you were supposed to put it back a little bit. And I was like, I'm not altering code. I don't know how this stuff works. Thing is, because it's healthcare software, right? This thing is an insulin pump. It runs an insulin pump. They have the good graces of the big companies doing this, but they don't have the liability structure of the big companies, right? The big companies are saying, cool, yeah, do this. This is great. This is really good work you guys are doing. We can help you in small ways. We would love for people to have a variety of ways that they could use our products that we really overprice. But they are unable to put it up on an app. You can't just download it automatically. They will not compile it in any way for you, because in doing so, they are distributing software for the use of healthcare, and so they are still subject to all of the same, FCC stuff, things like that. They have to get all the same approvals. They can't afford to do that. It takes a huge operation to do that. So what they do is they have you get it off of GitHub, you compile it yourself, you load it onto your own phone. You are responsible for that. But I'm not an app programmer. I can understand a little bit of programming, like a little bit. I can do pretty well in embedded systems, but when things get spiral out of control and you're doing app compiling, there are how-tos, but there's not a lot of information about doing this specific thing that I had to do that night at 3 o'clock in the morning while not getting my normal diabetes management at the same time. So I was up all night. I had to figure this whole thing out. It was a disaster. I'm so mad at my insulin pump company, not insulin pump company, the person programming AAPS. Other than that, AAPS has been absolutely fucking brilliant because it does exactly what you think all this technology should do. And it allows me to get more aggressive with management. I'm a big blimp, right? I got tons of extra weight on me that I wish I didn't have. But that's life. I got to deal with that. So I can turn this thing up to be turbo aggressive, and it can actually help me out. I write automated code to load firmware on devices. What a pain. Ooh, I had to do that in a previous job too. In a tracking device job, I had to update all the little modules. So you had these little modules you had to plug in, and then I had to do a specific sequence of events with specific Motorola software in order to update them. I had to write a thing that would teach the technicians how to do this so that I didn't have to do it anymore. Because I would have to do like 200 devices in a day. And I'm like, I'm an engineer. What am I doing? I probably could have written a program to do that. No, it's not whatever famous Motorola you suddenly, I know a Motorola product. No, these were specific data modems. Cell modems. Okay, I'm slightly rehydrated. Hey! Man. I know, I'm like older than every other streamer on Twitch. It's ridiculous. So we went in one direction looking for ground. God, I'm gibbery today. I've gone off on a couple different tangents today. But what we're trying to do is find out where this ground goes. And so we know that this node goes to like one of these over here. But that's not related to what we're doing. We're looking for a chip that we had previously identified, and I believe it's in this area right here. So what we're going to do is try to find ground and where it comes into this chip. Yeah, a lot of stuff happened during the pandemic. A lot of people started streaming. A lot of people like popped off. I partnered a little bit before the pandemic, and I've been going strong, but I need more people here. I'm super happy about that raid. That was very nice of hold on. I'm going back. I'm checking my where's my thing? Where'd my thing go? Cosmo Quest rated. That was awesome. Thank you so much, Cosmo Quest. Jackie Codes raiding with a party of 189 people. Any of you guys that aren't from Jackie Codes, go check out Jackie Codes. Yeah, there's the name right there with an underscore. Underscore supremacy. I really wish I could do an underscore in my emotes. OH underscore is what I wanted, but blew my mind. Opened up their code and was blown away at how elegant it was. Normally it's a nightmare mismatch. Schemas, all hacks being held together by string. If you really want to be depressed about looking at a code base, we've been looking and I've been working on stuff. I'll have to check out Jackie Codes. I try to stay away from other channels that do similar stuff because I don't want to take on their memes. Like I want to have my own personality, and I'm too much of a personality sponge. Ohm Ohm would be good, but it's not oh bother. Ob is kind of like ohm, but if it's ob underscore, then, because that's what I do when I have to make a name on like a server and oh bother's already taken, I'll do weird stuff. Yeah, OHB is it's okay. It's the best that I could do. We used to know, a couple friends and I used to know one of the big deal like admin people on Twitch. He was one of the staff. Had a 3-letter name, which is, you know, going all the way back to Justin TV days. I really would have Ohm is terrible because resistance is futile. Psychic damage. Okay, I'm good. We were going to try to talk to them about if I could get OH underscore, but then they disappeared, so I wasn't able to do that. If you want to see some code that's going to spoil your milk, check out some of the Hajiwo stuff, because Hajiwo does work quickly, and that means that your code can be very, very cursed. I'm working on reprogramming this thing, which is a spectrum and oscilloscope. It's just an analyzer for signals that are on a modular synthesizer, and Hajiwo makes some really, really cool stuff. He, you know, DIY $7 module, $7 if you've got all the parts already sitting around, right? Very, very cool stuff, and I hope to be doing more of his projects. It's just whenever there's like a microcontroller involved, I'm like, well, I don't really want to use the one he's using, so I'm going to use a little bit of a different microcontroller. All that means is that I should go in there and just replace a couple values in the header of the code. Nope. This is totally disorganized code, and it is, while it is fun to rewrite, it is tough to rewrite. There's a lot of stuff going in that Hajiwo kind of pieces together from various places, and yeah, it's cool, but man, 1 year in, I fixed everything, so now Twitch streams. Super bored this week, huh? But yeah, Hajiwo makes cheap modules, and they're really good. It's just the code in them is a little bit disturbing. Anyway, so back to the reverse engineering. What we're trying to do is we're trying to find where V- goes into the chip, and if it's pin 6, then we're in the right place. So far, I've been able to trace V- into the rest of the board without any power correction at all, which is a really irresponsible thing to do. Taking in your 12 volts just as 12 volts with no capacitors. Well, there is a capacitor on it. There's a capacitor on it, so we're at least smoothing out transients, but there's no reverse protection or anything. If you're actually trying to analyze anything other than just getting a visual representation of the spectrum, because you can't trust that it's tuned properly. Yeah, the modular, they're really trusting the mod, like the power supply, the modular synthesizer. And this is not trusting the people who plug in your circuit. This is encoding functionality behind a riddle. This is a riddle. You have to answer the Sphinx's riddle in order to power up your device, or else it'll explode. And you have to give it to your engineer friend to then, you know, gnash his teeth together about. This smiley face is the most pretentious smiley face as a result of this. If they had the capacity to put a smiley face on their board, they could have given us the minimal amount of markings to allow us to not plug this thing in wrong every single time. They even give you an IDC connector that's special and can be plugged in mid-row. I have another point of contention here. And I think it's kind of an important one. I just need to find the bin that I'm looking for. Where'd that bin go? There it is. Here's my other point of contention against this evil German manufacturer. They easily had space. Easily had space. Look at all this free real estate. Although there's a lot of free real estate because it's a surface mount design, so there might be some stuff in the way right here. Not really though. Not really though. You could move that. You could push this stuff back and forth. It might not be easy, but you could certainly have fit a keyed connector in here. Now this means that if you have a 16-pin hookup, some of these you can cut off for 5 volts and stuff like that, and this has its own regulator in it. It doesn't need 5 volts, but you know, just in case you want to use it, I guess you can. But they had room where they could fit a keyed connector. And they really should have. There's the Philly in me. They should have. So 5 cents at volume? Hell no, it'd be way less than that. Okay, so anyway, we're tracing out negative, and we're trying to figure out where all of our negativity is going, and we're trying to trace that back to a chip that has been shaved. Much like a Sam Squanch, it's been shaved, and so we need to figure out what pins that power. Is that actually the chip? Wait a minute. This might be the chip. If we were where we were, these are the, yeah, so this is the one I replaced. And then we were looking over here to see what this thing does. And it looks like our path to negative is as direct as they get. So, peeled it like a yank? Oh, like a yak. Oh, jeez. I thought you said yank. I was like, what is this? This is a new one to me. I've been around the block. I know some phraseology. There's never enough time to do it right the first time. I mean, yeah, that is look, I could defend Acid Labs. And I don't want to say too many negative things about them. I really just think the application of 2 diodes and or a keyed connector, or literally just anything to warn us, the word stripe would fit right there. Stripe. There. Right? That's all we need. If you just had said stripe. Right? That's the, I mean, who in their right mind would think to just very cleanly put something like text in a little box? It's not, you just can't do that. You can't do text in a box on a layer that you don't have a silk screen on. It would be impossible. Not even to mention marking, you know, the direction by putting the word stripe anywhere adjacent. What's up, Syphilate? How you doing? Hey, that was a sub. 40 months. 40 months. Thank you so much for the Syphilate. That's a lot of months, dude. Thank you. I appreciate you supporting me like that. Heat connector would have been the best route. Yeah, but then you need a specific type of connector, which is I'm all for, but we don't have followage for the last time. Yeah, even just a line by the connector. I feel like every stream I see the followage command like 5 times. We don't do that. First of all, because I didn't know how to set it up when I started. Second of all, because it doesn't matter. You guys are all equals. Silk screen next to pin 1. They don't have silk screen on this layer. There's no silk screen. So their only course, well, there's a couple things you can do, but I mean, what you could do is exactly what I did, which is just put something in the copper. Yeah, you can click on your name to see when you follow. It's just not public. No, yeah, it's okay. I mean, you guys don't have to be knowledgeable in EE stuff. I know Nicandria, and I hate to, she doesn't like this, but Nicandria does, when she's not doing like gaming, she does like lawyery stuff, Canadian lawyery stuff. And they're all talking about like all this lawyery stuff. And I can't get a word in edgewise. I'm like, where can I make a joke? Like, I don't know where to make a joke. I don't know what to say. I don't know what to do. I can't participate in this Twitch stream. It's interesting how intimidating it is. I'm like, wow, this must be what people feel like when they jump in on the EE stream, and I'm talking like the deep lore shop stuff. They just can't get a word in edgewise because it's so complicated. So I appreciate you guys putting yourself out of your comfort zone and trying to make a comment. I hopefully will never berate you guys because you're doing stupid comments. Like really stupid comments and stuff that I say a lot, maybe I'll get into a little bit, but don't take it too personally, because that beration, that little bit of scolding that you get, hopefully will help you learn. But I don't mean anything personally. These are Twitch comments. A lot of them are just people trying to have a silly time. So, and I hope you do have a silly time. Ask a silly question, get a silly answer. But you don't have the knowledge base to know that your question is silly. You don't know that you're asking a silly question, and so sometimes I'll come down hard on somebody and be like, "That's the dumbest thing I've ever fucking heard in my life," and they're like, like it's like, why did you say that to me? Like, I'm sorry. Anyway, this should probably have been diagonal. I don't know why they bumped this trace up like that. Maybe in a later revision they did it or something. Negative comes literally down here under the TL072. This thing should probably have negative in one of these pins. It might do another jump over to this pin, or is it this one? But then we're coming diagonally over here. We hit a diode, a resistor, a capacitor. So these are things that are dumping stuff to negative voltage. And then we hit 2 pins of this IC. This IC is a 1, 2, 3. Listen, you guys didn't think that I was one of these people that would automatically know how many pins are on an IC just by fucking looking at it? No, we're down here in the trenches. We got to count on our hands and toes. Take your shoes off, chat. Send me pictures. 1, 2, 3, 4, 5, 6, 7, 8. We got a 16-pin IC. 16-pin IC. Now, you might think that pin 9 is right here. Well, actually, you might not think at all. You might just be brain dead. And thank you for finding my channel. I appreciate you being here. Pin 1 has some kind of a marking on it. There's either a 45-degree cut all the way down the chip, and that'll tell you that your pin 1 is all the way on the left if you're facing it just right. Or there will be a notch in the top of the chip. Notch in the top of the chip, pin 1's over here. If there's a dot, pin 1's by the dot. Now here's the thing about chips. We are counting anti-clockwise around the chip, pin 1, pin 2, pin 3, because chips were born from vacuum tubes. Vacuum tubes, hold on, I've got an example of a vacuum tube. We started out with vacuum tubes because that's our understanding of electronics. We put stuff in a tube with pins sticking out the bottom. But how do you know what pins are what in a vacuum tube? Well, the more learned among you will see that there is a little bit of a space. There's a little bit of an extra gap right there. And so, with that gap right there, I don't know if it's from the top or from the bottom, but it goes pin 1, 2, 3, 4, 5, 6, 16, 15, 14, 13. No, it goes in anti-clockwise order around the tube. I know sometimes you just guess, but no, on this one, there's a gap. There's at least a gap. I don't know if it's viewing through the device or from the underside of the device. That's actually confusing with through-hole electronics too. That's one of my big things that I don't like through-hole. I don't like through-hole because you're like, which end do I view this from? But anyway, the point is, we're counting numbers like this. And so from vacuum tubes, we actually moved to, I don't have any examples. I did have an example. Wait a minute, do I have one over here? No, I don't know what happened to that. I've got it somewhere in my... We went from vacuum tubes to can. So the cans... Can transistor. And actually, you can... Wait, what the hell? Get smaller? Shut up. We went from vacuum tubes to cans, and cans are also round devices. And they've got a little notch on them in order to tell you where pin 1 is. And if you've got a ton of pins, I looked up transistor, which is 3 pins, but if you have a ton of pins, you're still counting them anti-clockwise around the circle. And so from there, we went to ceramic-bodied chips, the 2 pieces of ceramic. It's like an ice cream sandwich with some kind of celastic or ceramic in the middle that's been squished in, and your chip is inside of that. That has an exposed window because you can erase memory by exposing it to ultraviolet light. And I have a couple, I have those, actually those are right here. I have some of those. But you see, he is me. Got a bunch of those right here. We use these as microscope. Yeah, microscope targets. They don't have any data in them anymore. too young to actually experience vacuum tubes and cans. I ran into a lot of cans in my day because we were cleaning out old research setups, UPenn research stuff. And my ancient Dr. Britton Chance was the fellow that I was working for in like high school, and I knew him all through my adolescence. But I ended up cleaning out the basement of the UPenn area, and I really should have taken some parts from ENIAC, because there were two tri-walls, the big tri-wall pallet things that were filled with all the parts from ENIAC, one of the first computers. Dr. Britton sounds like a neat name. He used to smuggle a chimp into college with him, and he would hide it under his shirt in the big lecture halls. So the professor would look up, and it was one of these very serious professors that like never reacted to anything, and he had a chimp. He was famous for having a chimp. Like, I don't know. He was also an Olympic sailor, so that was kind of cool. I know, people were different back then. They were made of different stuff. So anyway, the point is we go from tubes to cans to ceramic substrates to epoxy. So here we are with epoxy substrates, but the the number stuff is the same. So we count 1, 2, 3, 4, all the way up, and then 5, 6, 7, 8, 9, 10, blah, blah, blah. So that's why these are this way. Pin headers are totally different and obnoxiously confusing. With something like this, typically you would have a pin marked as pin 1. Now, on the pads themselves, you will often have a square pad on pin 1. That's one indicator, square pad on pin 1, or a mark to tell you which side of the connector is which. But connectors do not count anti-clockwise. Connectors go something like 1, 2, 3, 4, 5, 6. They go back and forth. Why they do that? It's probably just intentionally to confuse us. Now, if you have something like a resistor, it goes pin 1, pin 2, right? Pin 1, pin 2, and that's actually clockwise. Pin 1, but no, it's, I don't know, whatever. When you get outside of ICs and pin headers, things kind of break down, and the numbering becomes like almost pseudo-random. So anyway, the point is we have ground on these two. Why? Welcome, Hedonica. Hedonica asks, Father, why is this one chip scratched off? Oh, I'd love to tell you, but I don't know. Could it be that they were trying to keep us from finding out what the chips do because they selected these chips specifically to emulate the M303 of yore? In 2014, some asshole decided that they would try to hide the identity of the chips and keep somebody like me from reverse engineering it. But that doesn't stop us. We're better than that. That didn't stop me when I was doing IEDs. Oh no, that just gets me mad. And that means I dedicate more time to the project when I get mad. What we do is we look at the surrounding electronics for the chip, and then we lean on that oh so wonderful amount of experience that we have in working on chips like this. Can't tell it's serious. I'm dead fucking serious right now. They scratched off these chips in order to keep you from repairing this device or reverse engineering it. And all that does is slow us down. Now, this slowed us down in a big way because I don't have experience with this kind of stuff. I don't exactly know. Decap it and pull an electron microscope. So there was a meme that went around, right? And of course, being me, I'm always 1 degree separated from anything that goes viral. Nothing of mine can go viral for some reason. This meme that went viral was somebody, not meme, this thing that went viral was somebody opened up an old AMD produced, like, I forget what it was. It was like an amplifier or something like that. And they zoomed in on the silicon substrate, and there was a smiley face on it. And so I actually made my own version of this. It's floating around somewhere where I look at the meme and I go, ah. And so I get one of my own and I open it up, and then there's nothing. And I have a picture of me like, ah. There was nothing. They moved one of the traces on the silicon substrate, and they discovered that somebody put a smiley face on it, and they said, no fun, and they deleted it. But so I tried to look for one of these cool little Easter eggs on a circuit board, and I wasn't able to find it because it was a slightly updated version of the chip. Yeah, they don't put the name and serial number on that, but sometimes you'll get Easter eggs. And sometimes in the older data sheets, you have a picture of the chip. So what the reason we talk about all these different numbers and stuff is you can have multiple different packages for the same exact chip. You can have this type, you can have a through-hole type, you can have one that has like a ball grid array under it, you can have a varying amount of pins for your different packages, and you can have different ways to mitigate heat. So, oh, my neck just cracked. I can't feel my legs. Yeah, so anyway, the point is you can have different packages for these different chips. This is SOIC, nice comfortable surface mount size. No, it didn't do anything for me. It just made a very loud noise. So here we have this chip, and we don't know what it is, but we do know that negative power is coming into 2 pins. Those pins are 1, 2, 3, 4, 8, 9, 10, and 12. So 10 and 12 are getting minus voltage. So if we look at the data sheet for the chip we were told, buffer input and output. Okay, that doesn't make any sense. Is that actually getting negative? I wish I had, so my mixer, when I do game streams, I have the mixer, and that's got a bunch of different sound effects on it. So I have the garbage crash with the cat screaming. I have what's called the Curl and Nescar by Red Letter Media. It's just a pot breaking. And if I knew a soundboard a little better and had access to one, I would absolutely do that gag. That was, and I've told this story on stream before, FK, when we were studying in college in the middle of the night, and it was like 2 o'clock in the morning, and FK Productions is sitting next to me, and we're like at our ends. We're in like this totally unoccupied like student lounge, studying some really hardcore engineering stuff. And I look over at him, and he hiccups and then just dies. And I don't know, tired brain. I thought it was the funniest thing I've ever seen in my entire life. He did it for nobody. Nobody was necessarily watching him either. It was just a perfectly like pantomimed hiccup death. I was in Discord where somebody was probing the surface of an MPU to manually flip the security bit. They do that with lasers. They actually do that with a laser focused in on that security bit. Yeah, it was perfectly done. It was perfectly executed. What's harder, decapping without damaging the bond wires? Don't you just use sulfuric acid? Doesn't it not hurt the bond wires? Maybe they have ways to tap in on the bond wires too. Decap chips like this and looked at it under a regular microscope. Sulfuric and nitric acid with chips on a hot plate. Oh, you have to use a hot plate. In about 30 seconds with 10 milliliters of acid, you have dissolved epoxy package. We've done it before with just sanding off the layers of the PCB until we get to the bubble that the chip is in. And if you have a can, the can is it's just got atmosphere in it. So I want to pick this thing out and replace it, but I need to make sure that it's what we think it is. Now, we did a little bit of analysis of the circuit before, and I kind of wrote down what was connected there. Oh yeah, so 10 and 12 are not what we thought it was. That's not negative power. I have a feeling that negative power is taking a turn then. We don't get to see through these things. We don't have an X-ray. I actually used to have access to a three-dimensional, well, I mean, everything's three-dimensional, but it was a 3D X-ray microscope. And so what you were able to do is do a fly-around view, as if you were in like a little tiny helicopter with an X-ray flying around the chip, and you could actually see the epoxy substrate was just like a shaded outline. And so you'd see inside of the package and how all of the wires go and meet with the chip in the middle and do like really cool views of that. That was a crazy piece of equipment. You could also remote operate the whole thing. Yeah, I don't think I'm doing the DIY X-ray. I am not, what's his face? Not Tech Ingredients. I'm not Applied Science. Applied Science has that full fucking X-ray setup. Is nuts. Absolutely crazy. So I don't think we're actually connecting to negative. Here's our negative line. I don't think that's what's going on here. So negative is doing some shenanigans under the board over here, and it's probably connecting to probably this one, because it looks like this is the decoupling capacitor right here. So this is probably positive 12. This is negative 12. This one would be connecting down here. Oh, there's another decoupling capacitor right there. Oh, it might be different stuff. But okay, so 12 volts coming in, probably goes to here. Let's double check that. A backyard X-ray. Yeah, if anything, I would have a remote X-ray. I'd be like, let's go put this in the X-ray in the other room. It's like when you get an X-ray at the hospital, the operator runs and hides in this little booth. Like, how safe is this? Man, UPenn had like a satellite dental setup around here that went under. And I wonder if there's any way that I could take advantage of that in order to get, like, if I had a dental X-ray, that would be so awesome. The problem with buying just any old X-ray, like off eBay, is usually they're for sale because the tubes have gone bad. And if the tube has gone bad, all kinds of weird X-ray shit can go on. And I just don't want to deal with that. I don't want to deal with weird cancer stuff. You know, Uo's lab does a lot of crazy shit. What's his name? The eyebrow guy does a lot of sparky shit. I'm wearing an insulin pump. I really don't want to tank my diabetes management just for content. So I don't do a lot of crazy sparky stuff. Styropyro. No, he just recently got his degree, I believe. Is that the right person? Am I thinking of the right person? Didn't he just get a degree in chemical engineering or something? That's that Aussie guy, right? That blows stuff up all the time. I think that negative was going down to here. Let's check this via. So I poke it really hard. Nothing. Right here. Oh, that's different then. That's a different. I think that might be a different person than what I'm thinking of. Oh, explosions and fire. Thank you. Yes. That's another one of those crazy channels. So that's not negative. Where the hell is negative going? Here? Negative voltage is a relatively unique signal on this board. It's good to trace out where it goes to, because that'll give us sort of a unique identifier about this chip. Not a lot of stuff uses negative voltages. So we happen to know that this pin, 1, 2, 3, 4, 5, 6, has a negative going into it. Oh, that's the dude with the really high power blue laser? That starts to get into the segment of YouTubers that I sort of don't like. They make very dangerous things look very casually not dangerous. And while they are very smart people and they know how to be safe within their own wheelhouse, they make it seem very cavalier to buy a bunch of 6-watt lasers and play with. There's a lot of stuff that you need to do in order to be careful around that kind of thing, right? So I try to talk about whenever I'm doing stuff like a certain way to be safe. So V- is on pin 6 of this thing. So that looks like it is the right thing. And it looks like I've already done a little bit of circuit tracing on this. I don't want to double up my time too much. Styro emphasizes safety and not doing things. Okay, good. Because what happens is that gets peeled off into a TikTok, and then any of the safety information that they go over gets, you know, replaced with a booty song, and then it gets put up as a 15-second blurb, and then some kid sees it, and I've interacted with those kids on my stream. I've had them come in and ask questions about how to build extremely high power laser arrays, and I say, don't. You want to start with something that's not going to blow up your house, right? Like, damn. So, we know kind of the identity of that chip because we've looked it up before. We know that it is, in fact, this chip right here. The TL07 2 and 4, I had taken out already, and I don't think it would break just from reverse voltage. We have reversed one of these connectors, and it had sort of disastrous consequences. So it's possible that more stuff is broken on the board. I want to replace this one right here, and we'll see if we get any functionality out of this module. And we would have done that more completely, but we had a very distracting time, and we've been talking shop. And I work in a shop, so I talk shop. It's been a very fun stream. I've had a good time interacting with everybody today, except for that one guy. God. So I am going to hot air remove this thing. You don't necessarily need hot air if you're removing a chip like this. It's just a little bit more annoying. I happen to have a hot air station. If you find yourself soldering stuff on a daily basis like I do, it might be a good investment to get a hot air station. It might be a really, really bad investment to get a hot air station, but they're not as expensive as they used to be. This one is the super duper Louis Rossmann special. Chat bought me this a million years ago because they thought I was getting a 3D. Well, they were going to get me a. Okay, hiccup and then talk, all right? Chat thought that I was going to. No. Chat thought they were going to get me a 3D printer because I hate 3D printers. I still do, a little bit less these days, but I hated 3D printers back in the day because, you know, we have 2D printers and they're not even good at what they do. Now we're adding more dimensions to this, but I have turned around some of my opinions on 3D printers. After having used one for long enough, it turns out people are lazy and 3D printers are actually pretty good these days. So I was going to have a friend drop off an old 3D printer, and I was going to use that and get to know that. That didn't end up happening. I ended up spending a bunch of money on my own 3D printer. But in the interim, they were like, well, we made a Discord, and we pooled all this money to bother a cool thing. What do we do? And so they sent me a bunch of odds and ends. And one of the odds and ends that they sent me was a hot air soldering station. And they got specifically the Louis Rossmann one because I constantly bitch about Louis Rossmann using too much flux. I dislike flux, but I also told them that I was good at hot air soldering. It doesn't take much to be good at hot air soldering and reworking. But they also got the special tips, the 45-degree angle tips, which are very nice when you have an overhead microscope. Yeah, make sure you get a 120 volt one. I actually put 220 in the wall. It's like behind the milling machine, but that was for the brewing setup. So I happen to have the ability to plug stuff like that in, but 120, yeah, get the right voltage. By the way, you don't have to buy this one to get good hot air soldering these days. Europe, look at yourself. I'm Adam you. I have too much brain damage to read this comment. For some reason, when you at somebody, I don't see it over on the social stream thing. So I guess I've got to look at my other screen to see what people are actually saying. It's so weird. Where's my chat for? Huh? That's weird. None of the chats for YouTube are showing up on the YouTube page. Oh, did I pop out the wrong one? No, but we saw Madam U up on the thing, so strange. All right. Anyway, sorry. Background stuff that I need to worry about. Okay, so we're going to desolder this chip. There's a couple different ways that you could desolder stuff if you don't have this equipment, right? Yeah, it's like a threaded reply, but for some reason my social stream thing doesn't pick it up. One of the ways to desolder a chip like that is to use a big soldering iron tip, add a bunch of solder to both sides, and just get that heat in there as much as you can, as quickly as you can, and have all of the pins remain molten at the same time, and then the chip will pop off. You do have to worry about whether or not the chip has been glued. If it's a 2-layer surface mount PCB, especially this era of surface mount technology, the way that they'll construct it is they will put glue under the chips and they'll place the chips down on all the pads, and then that glue hardens, holds the chips in place, flip the board, do the other side, put it into an oven. So sometimes, and this happened when we were doing a synthesizer mod for Julian, you have to like crack the chip off of the board. Now, the problem with that is it's hard to tell if it's glued down or if you've got a pin that's still holding on. The thing about surface mount pins, individual pads, is it is just a pad. It's like a sticker that's been placed on top of the table, and now suddenly you've got a lot of heat and a lot of mechanical force on this sticker. Those pads can just come off. So you got to be careful about that. One of the things that I advocate for doing surface mount like this, and that, by the way, if you are cool about sacrificing the chip, you can go in pad by pad, heat it up, peel the pin up, heat it up, peel the pin up, heat it up, peel the pin up. You got to be careful about the last couple ones because then they have this big moment arm connected to the rest of connected to just your surface mount pad. Alternatively, you can get something like Chip Quick. You got to be careful when you buy this stuff because you got to buy just the right stuff. Just the right stuff. The stuff I use Chip Quick REM 4.5. This is a desoldering alloy, and it's expensive. It's not cheap. This stuff is. I think you can also just get the base metal too. I forget people are saying it's like boron or something like that. But anyway, you add Chip Quick to the two sides. You put a lot of flux on there, and Chip Quick is molten at a much, much lower temperature. And so when you add Chip Quick to both sides, the chip will just fall away. It's kind of amazing. I need some help with a double-sided board and soldering some ICs. Tiny stuff. There, I can help you out with that. That'd be fun. The side with fewer components is the one with the red glue under the chips. Ah. You can also use Rose's metal or Wood's metal, which is a cheaper form of desoldering. Gotcha. Yeah, this is just the stuff that I was introduced to. Ah, bismuth. Was that the one? Yeah, it's not boron. Bismuth. I just watched Chernobyl again, so I've got all these weird metals in my head. So Big Tip will help you get a lot of heat in there, and then something like Chip Quick can help you keep it all molten at the same time. Chip will just fall off. Wood's metal uses 10% cadmium. You're just making up metals. The way that I'm going to do it is using hot air. And hot air, I just basically heat up all around the chip and then focus a little bit of heat on the chip itself. And you've got to really be careful not to unseat anything surrounding the chip. This is a big enough board. Usually I'll put down like a silicon thing on the table. Do not eat. I'm not making any promises. But yeah, those are the methods. So you don't need the fancy stuff in order to do this, but somebody bought me the fancy stuff, so I am going to go ahead and use it. A long pair of tweezers would be comfort. I don't know if I really have. These are way too serious. These are like gonna cut stuff. Cadmium egg. I guess I'm just gonna have hot fingies. So you guys can look at the thermals while I do this, and it'll look kind of cool. The chip we're removing is right here, and we're just gonna get a new chip in there. I'm gonna get my light over here. I've had a lot of trouble with my light lately. I think I need something that can. I need soft light that can get closer to the circuit board. I don't really know how to do that. I just have this big barn door light sitting right next to me. So what I'll do is I'll press my finger into the tweezers, right? Because the tweezers only open up this much. So what I can do, push my finger in there and then put it on the chip and remove it. And now a little bit of pressure is being held on this chip. And so I can try to move the chip this way, and I don't want to put too much force into it. I just want to surround it with lots and lots of heat and then kind of push it in a direction or two. Because what can happen, the worst thing that can happen is if all of these pins are molten and one of them isn't, and we move it and it rips up the one pad. Actually, in order to mitigate that a little bit more, I'm going to put flux on the pins. So this is tacky flux. It is a material that I hate. It gets everywhere. It's annoying. But what it does is it locks out oxygen and it holds in heat. And it'll clean a little bit of the oxidation there in conjunction with the heat that you give it. So I'm just putting a little bit on all these pins, and that's actually probably too much, but I'm just going to make sure that these things remain in flux, because this hot air solder station is going to burn away a lot of this flux as I work with it. I have this thing set to 500 degrees. My soldering iron's set to 666, but I guess this one's 500 degrees Celsius, so it's not the same. It's quite a hot thing. I got to be careful because this thing will damage the circuit board. It'll damage my desk. It'll give me brain damage. You know, all the damages, all in one, all at once. Welcome to electronics. Make it a little brighter. Ooh, we're using cellular internet. So we start by just heating up the board because we don't want to shock anything with too much heat. So we get the board a little bit warmer than it was before. We just make sure to get that heat kind of spread around there, and that's going to make everybody a little bit less shocked when I go in there and actually blow up the chip. It's okay, we already have brain damage, yeah. I know. All right, grip the chip, and then come down here, start pressing the issue a little bit. Now I'm still like a half an inch away. You can see on the arm cam. I have an extra entire thermal setup I would love to figure out, and I don't know if I can afford the lenses because you need like special infrared lenses, but I would love to be able to set up an infrared microscope. That would be amazing. I don't know what it would take though. All right, there, everybody's gotten a little shiny. So let's just keep the heat in a little bit more. Let me go down there and actually press it in. There it is, nice and easy. Now this goes back on the base. The base has a little magnet to detect it, and it'll ramp up the fan in order to cool off the tip. And now I've just got this hot, dead IC. So that leaves us with a mess of flux. I'm going to leave that flux there for now, and I'm going to take desoldering braid, and I'm going to remove all the excess solder from all the pins. Now I could solder it back in with hot air, but I'm not going to do that. You know, you could dedicate yourself to the hot air. You can live by the hot air. You can die by the hot air. I don't do that. Hot air is kind of special for me. I could have said that, but I have more than one brain cell going simultaneously, which puts me in a position to be called a very smart streamer, but I'm really not. What capacitors? Oh, the plastic on the capacitors? We were avoiding that pretty well. You can put up like a piece of Kapton tape, can actually block the heat from getting over there, but it really is not, that's not in too much danger over there. You can see the heat's tapering off pretty quickly, and when you get to the capacitor, it's on the edge, but these electronics like this are pretty robust. It's a good thing to consider. It's good to have a mind on that, though. Yeah, caps are pretty robust. So, all right, I'm gonna get a slightly larger tip on this thing just so I get heat into my solder braid quickly. We'll go for the mid-size tip because this stuff does not need anything special. The wedge, not the wedge tip, but it's like a chisel tip type thing. And this will get a lot of heat in there. The typical size that I use for this type of electronic soldering is this one. It's a nubbly but nimble tip. It gets into stuff, but it's not the needle tip. The needle tip is for much smaller surface mount sizes. And whenever I have to get the needle tip out, I know I'm going to be angry that day, because the thing about smaller surface mount electronics is they look a lot like this stuff. This stuff is great. They left, I mean, look, Acid Labs, say what you want about them, but their board design is very nice, because look at all of these components. These are 0805. They might be 0603. No, I think these are 0805. There's a nice amount of space around everybody. You can get in there. You can get your tool in there without melting everything. It is a nice place to be. It would be a nicer place to be if they didn't sand off all of the identity of all of their stuff, but still, this is a nice size to work in. I like this. I can work with this. I can do all kinds of manipulation to this stuff. So yeah, get heat in here quickly. Oh, this isn't even on. Turn on the soldering iron first. See how quickly the heat gets into that. Bada bing. All right. Just use 2.4 millimeter chisel tip for everything. Well, yeah, this is a very universal tip. But yeah, this size is like hand solderable, and you can do all the rework stuff with it all day. All that flux we left behind is helping me out with this. Now I need to move up on the solder braid a little bit. Ooh, I'm holding the solder braid by my hand. I should get a little toasty. So I'm going to rely on the fact that when I press down here, this is going to lift up a little bit, and I just don't want to run into this capacitor right there. Move up a little bit. Do this until you see the visual azimuth, the thing wicking in. This is the same principle by which a pipette operates, only solder is a lot more viscous, and so that surface tension is used quite a bit for operations with this. You can remove it quite efficiently by heating it up. All right, now, if I wasn't a turbo asshole, I would clean this thing up. I happen to remember that pin 1 was on this side just by luck. We're lucky that I remember that. So we're going to put the new chip in, and so what I'll do, and I actually bought smaller solder precisely for this sort of thing. I bought slightly smaller solder. I got sick of having blobs everywhere. Blobs are fine as long as you don't have cold solder joints. Cold solder joints are when there's an imperceptible crack on your solder joint, or if solder is just sitting on top of the pad. So having that little bit of flux that we put on earlier, just having it present in the face of this thing is helping us out quite a bit. So what we have is a little bit of solder on one of the pads. You can see that the solder's flowed over the pad as if it were a drop of water on the floor, right? You want to make sure that, that surface tension is flowing. It's all about looking smooth and flowing. And a lot of the stuff that I do here is muscle memory. And it takes a little bit for me to figure out what I should be telling you guys in order to teach you how to solder. Because I do fashion myself as educational. Here, I'm going to move the hot air station away. It's funny though, the soldering techniques, I've had professors at universities rant to me about how their PhD students don't know how to do the first thing with soldering. I'm like, dude, just like tenure, give me tenure. Just give me tenure, I'll teach them. Oh, hold on, I gotta put that thing so it's out of the way. All right, so need a one-handed wick cutter. It'd be like a label maker kind of thing. I'm sure there's some like one-hand soldering setups on Thingiverse that are actually pretty fascinating. You should look at those and see if anybody does what you want. Press down on that, and then I'm just gonna maneuver this thing onto one pad. Now, like I said before, this thing is relying on one pad to keep it in place. So I've got to be really careful about twisting and bending it in ways that it's not supposed to, because that will cause it to rip up that pad. So I'm going to grab it here where I can press down a little bit. I'm going to melt that again. Did my soldering iron turn off? No. I just want to position it again. Let's make sure that I'm happy with that. That's pretty good. It's not going anywhere. You see it move a little bit, and there's a little tacky flux underneath it. Now, what you can do is drag solder these pins, but I've had bad luck drag soldering stuff like this in the past, so I'm kind of going to go pseudo-individually and just take it on a case-by-case soldering basis. So I'm going to start over here. I'm going to anchor down the opposite end. You don't have to do it in a specific order, but I just like to hold things in place. You can see there that the solder sat on top, and then as soon as all that flux got around it and the heat, it decided to settle in. Now I could go individual pin by pin and just do that to every single pin, or I could load the soldering iron up with solder, put some flux down, and then basically rake across the pins in order to leave behind solder. Why is nothing happening here? Change my angle. Hopefully my angle of attack will change the nature of this thing. I may have to drag solder this. Oh, we're all the way over to one side. It's fine. We'll just accept that into our heart of hearts. I could always run hot air on it afterwards in order to... Okay, there's too many shadows. Too many shadows. I need to move this thing up. This is the problem we've had before where I can't see what I'm doing because we're soldering against the table. But really, this whole setup is designed to have the circuit board sit up on something. This is going to move around too much if I do it this way. If I plug this in... If I plug it in directly, like that, and then I clamp on the side of it, that'll hold it in place. Then I'll be able to work. I'll be working over a giant spring, but that's fine. I've done worse. Actually, no, the spring's on the other end. There we go. That's so much better. Hopefully my hands have less of a shadow now. The shadow knows. There's our unsoldered chip. Look at how crooked it is. I could do hot air on it, and then surface tension would even it out, but whatever. What? 9 year? Oh, 10 year, right. N minus 1 year. My shadows are still so huge on this. I don't know what's wrong with the setup lately. If I lift the light up, I don't know if that'll help. I think I lifted the light up last time. Do it like facing down a little bit more. Then I lose my spring arm mobility, but maybe this will leave fewer shadows on everything. I think we've just dealt with the shadows and I wasn't as frustrated about them in the past. do kind of want to even this thing out. It is pulled all the way to one side. Whatever. Just like welding, when you're soldering, comfort is key. If you are uncomfortable where you're soldering, your work is going to suffer. Brazing is very forgiving, very, very forgiving. And it's, of course, you can clean everything up and redo it more than you can with welding. But if you are comfortable and you've done the proper amount of prep work, then your joints will thank you, both your physical and your solder. Doing this pin by pin is very obnoxious, actually, to be honest. This should maybe be done on a rake as a drag solder operation. Doesn't really matter what you're wearing when you solder. I mean, you can drag solder, you could cross solder, it's whatever you want to do. But the specific operation I'm talking about, yeah, happy little joints. We're going to just use the fan blade on this one. No, but when you drag solder, it is an operation where you are raking across the pins with the soldering iron. The solder flows into the pin, and then surface tension pulls away all the excess with the iron. It's something like what I'm doing right now, but this is more of an official heat up individual pin, add the solder, pull it away. Whereas with drag solder, you just have a ton of solder on the blade, and you flow across the pins, and it leaves behind a near perfect solder joint. You know, these have a little bit of excess solder on it, but that's okay. I don't know if that one on top looks too soldered, does it? You kind of have to get an eye for stuff that doesn't look soldered. And it's going to depend on your microscope setup too, because I wouldn't suggest going out and buying an entire microscope setup when you can get a pair of glasses with a headlamp in it. For a lot of these crochet people use it, or no, sorry, needlepoint. Needlepoint people love those things. But you can get a little piece of headgear with a headlamp, and then because your eyeballs are so close to the headlamp, you don't get a bunch of shadows on stuff, and you can really identify things that you're looking at. I think I'm dehydrated. I'm getting a big headache. Yeah, just to get us back to where we were, I should scratch all the leads off. All the number stuff off. I don't think this thing is going to work, but we do have it set up so that we can test it again and see if we actually get any audio output. Because that's what Dave was saying, is that he didn't get any audio output. But on the oscilloscope, everything looked like it was functioning just fine. So I have a feeling that it's due to, well, it's possible that it's due to this audio amp dying. I have extras, so, and I don't know if I need to replace those transistors still, but let's just fire this thing up and see if we can get anything out of it. So I'm going to turn on the oscilloscope. And while we turn on the oscilloscope, I'm going to get a drink of water. Hopefully, I have time. Neighbor's dog is barking. There's a truck backing up out there. Willow joined in. She's barking too now. We have the two dogs in the two neighboring households barking at each other. Willow's barking at Millie. Millie is barking at a truck. Willow finished barking. She's not barking anymore. Welcome to the year 2024. Our oscilloscopes boot up in under 1 minute. There it is. Nice of you to join us, oscilloscope. I guess see how long that is. It's an Android something or other. It's basically a tablet with oscilloscope software. I love Rigol. I think they're an amazing company. They make some really nice stuff. This is at a price point. This is something like $700, which is affordable for a piece of test equipment you're going to use basically your whole life. But a full minute. Yeah, my old Catha. Okay, so we were talking about ENIAC earlier and how I didn't hang on to any of that. There were also a bunch of oscilloscopes in that lab basement. and I did not keep them because they were big and bulky, which was the dumbest thing I've ever done. I loved my oscilloscope. I knew that thing inside and out. I also had a vacuum tube oscilloscope. I should have kept them. I should have kept them. It was dumb. I really was dumb to get rid of those. I love the form factor of scopes now. It's just a little tiny desktop thing that you can move around. It's got a nice big screen, and digital screens are good enough now that everything is totally fine with these. But man, to have an old cathode ray firing into your brain, and you knew that all of your switches did certain, yeah, it was nice. It was nice. I do have another ray based scope here that a viewer sent in. It doesn't work, but we could maybe get it working at some point. But that's another project on the pile. I'm not allowed to start new projects right now. So, okay, we got this thing all set up. We got a new chip in here. Wow, that chip is all the way over to one side, isn't it? Why didn't I see that before? I think Parallax did that. See how it's like way over to the side. I could fix that with hot air if I just put a hot air on it, but we won't mess with that right now. Massive Tektronix scope when I was a kid, one of the big ones that was built into a cart. Yep, same. Mine wasn't built into a cart, but it did have the cart. It was this massive, and I do this because I'm at a smaller scale, but it was like on a sideways cart. That thing was cool. I think mine was HP. I think it might have been Tech. No, was it Tech? It was blue, not bright blue. It was like dark blue gray. Hey, what's up, Caravos? How you doing? Okay, so we've got this thing. I've got it. I'm going to plug it in. Whoa, I'm going to actually plug it in correctly. Hold on a second. Reversible PCBs. I was like, why didn't the screw holes line up? Plug it in. So we're all connected to our front panel. Boy, it must be nice to design stuff like this. So you got all this room on the front panel, then you move to the back panel, and you got all this space for all your... They space everything out nicely. That must be nice. We kind of crammed everything into this one board, and I've even got the microcontroller all on its own thing. I still had to fit all my circuit stuff in here. It was a nightmare. Okay, so we've got this thing. I'm not going to attach the front panel until this thing is fixed. We need to test it. And so what I need, I have a signal generator. I have a scope. We put the scope up on the screen. Where is that overlay? I really should have made that module tester module, shouldn't I have? Maybe that's something to make in the future, but that requires like all this software. There's the scope. I have a big headache for some reason. I think maybe because I've been talking all day, like gibbering on, because we got like a big raid, and you have to be nice to the big raid at my level. At my level, you got to be where did my solder? Oh, there's right there, right next to me. I'm trying to make a little space on the desktop so that we can actually get our testing lines in here without getting completely overwhelmed. This will be our probe. We have an input from here and an output from Stream Deck. Are you on our Discord to tell us about the foot pedal? I think you got the wrong one. Oh, getting ready to make a 3D foot pedal with a larger face. Yeah, jump on the Discord and tell us about that. I love hearing about everybody's projects because it gives me a little bit of hope for my own. What is happening here? Why are we moving all this stuff through the stream? What is, you son of, it's like dragging everything. Oh my God, my whole desk is become unraveled. I am become mess. God damn it. I like my clean test setups. Sometimes it's hard. Sometimes you have to have a little cry to have a clean test setup. All right, so everything having fallen down and away. Jesus. There we go. There's everybody. The cool thing about the scope is that I can have it up on screen right now. With these new Rigol scopes, what you can do is your boss can pull up the web page of your scope and edit stuff by clicking the screen, which actually is somewhat of a good thing because you don't have people breathing down your neck to view what you're doing. So it's somewhat okay. It's not great, but it's somewhat okay. All right, power. So the way that we've been doing power with modular synthesizers is I've got 3 probes plugged in. I've got 3 clips plugged in. And so we'll set one to be positive, set one to be negative. And that's just something that this power supply does. So nice and easy to get all set up here. I just need to kind of deal with my mess a little bit. I have to clean up, basically. So, I'll put us off. Let's turn. So the unfortunate thing about the Agilent power supply that I have is that in order to set the voltages, you have to turn it on. So you have to like unhook it from what you're doing, turn it on, go to plus, set plus 12, which is now outputting. Go to minus 12, set it to minus 12. So now it's outputting plus and minus 12 volts. Now I can turn it off and hook it up. But that's such a weird thing that it does. By contrast, the Chinese power supply that I have that I built doesn't turn on until you hit the power button, which is a separate button from the thing that sets the voltages. You come over here. Jeez, this has been sitting here for a while. We're running out of view space on the screen as well. All right, so I'm going to unplug these. This is my alternate power plug. And then on this plug here, I can go to one end, and my minus 12 is the different type of cable. Different kind of cable. So we go minus there. Which one should it be, though? Oh, they're all connected together, I think. So minus, then ground in the middle. So the middle 3. So skip 1, ground, and then skip 1, positive. So there's our power. Foot pedals, just extra buttons that use F13 to 24 keys for people that need them. Friend wanted a wider face. If I finish the design, I'll post it. Hell yeah, brother. I want to see that. Okay, so then according to the picture, we want to make sure we get this right because this is what killed the thing before. I want to plug it in like that. You will not find this information anywhere else. It's ridiculous. Okay, so. But the stripe needs to be at the bottom. So it needs to be like this. Although it's going a different direction, they're universal, right and left. Yeah, they use ribbon cables in modular synthesizers. It's one of the few places left. Ribbon cables are nice and easy, though. They're very fun to use, and you can split them apart and solder to them, and the pins can take a lot of current. Okay, so CVN comes in up here, and our input is plugged into the non-red one. I need to put shrink wrap on these so I can actually identify them. So this is control voltage in. And actually, we want that to be VCO CV. So I want that here. VCO CV. So the frequency generator will control what frequency this thing outputs. And then we're going to have our output on out, all the way at the bottom. We'll see if we get anything outputted here. Get the dog hair out of there. Okay, and then I need to enable 2, 3. 3 is the probe. But we can't really probe it unless I hook it up with the ribbon cables. These are pretty good. These are alternatives to the Thonky Kongs. I'm pretty sure Acid Labs could have made this a much smaller module. If we went through the trouble of fully reverse engineering this thing, I could probably make a slightly smaller module that does exactly the same 303 stuff that this one does. It would just use Thonky Kongs and everything would be a little bit more compact. So we put 12 volts into it, but we make sure that we observe heat. The only way to observe heat is to view in from the side like this. So here we go. Boop. 0.19 amp. We have a little bit of heat in these two over here. Uh-oh, that's not good. That's looking a little bit too hot. That's looking a lot a bit too hot. Do we get any response out of this thing? Yeah, we should be getting a response out of it. Cool, cool. I mean, I'm not giving it an input signal right now, but we should still see at least a frequency coming out of it. So we get nothing. Good day to you, sir. All right, let's power this down. That heat should linger for a long time. So that's the transistor array, I think. Or was that that's not the transistor array. I mean, this chip right here is the one that we probably need to replace again. I could have blown this up when I messed up the front panel. Now, I know this looks like I'm not plugging it in right, but that is the stripe pin. The stripe pin goes to the bottom there, and that feeds the rest of the circuit. And we were using current, so stuff was happening. We were just using it to heat up a chip. So, and there was 0 audio output. So this right there, and I think that is the array of transistors, and it's got a couple tuning pots right next to it. And we don't need the scope right now. Boop. Man, as much as I would love to fully reverse engineer a 303, I just kind of want to get this project out of here. That's a very... Get out of here, hippie! Thank you for the positive vibes. It's so shiny. Yeah, the solder's a little bit shiny, and I guess the angle of light is hitting it just right. Let me get the lamp in here. Blow out the light here. So. L2240F. Wow. Wow. L2240. Fah. L2240. L2240 FA. Ford got a new computer. Oh, hell yeah. Things are happening just a little bit faster for a little bit. I've gotten too used to my new computer. We built that. Oh, God, when did we finish the water cooling stuff? It was like a year ago. I think this stuff just happened, and it was like a year ago. HFA 3046? Oh, 3046. Yeah, so this is the 3046, which is heating up quite a bit. So we should probably pop this sucker out and put a new one in. Listen, if God is watching me right now and he represents that many views, he can fucking do a little bit of work and get on my viewer list, because, like, shit. I could use the viewers. All right, so I'm plugging that in, but we're not going to run power through it. 7,800. Oh, man. What do I have? 56, 50, 69? I don't know. 6950? No, that's not right. I got some kind of a Ryzen, but I don't think it holds water to yours. That's a nice one. All right, we don't need the scope. Scope? Where's the scope? It's somewhere on this list. I need to put it on a deck button. Ryzen 3700 from 2020. 5950X, and it's from like 2021. And it's the super duper new computer, even though it's already completely obsolete. But not on this computer. This is the... Oh, that's the wrong camera. Not on this computer. This computer is the streaming computer, which is some kind of Intel and my old 1080p FTW. 1080 FTW. The P snuck in there. Let's get this transistor guy out of here. That, I think I blew up by plugging in the front panel wrong. So that's the one that's heating up. If we get another new one of these in here and it still heats up, we're in trouble. The one we put in didn't heat up though. That's nice. So let me get one of these guys over here. One of this guy right here. That little guy. We'll put him in there. 3970. Yet none of us will need to upgrade for decades. 100 case opening knives. Case opening knives? That's called just like the knife you carry around normally. Or is it like you're opening a detective case with the knife? Is that what it is? You're like, it was a dark and stormy night, and then you go stab some MF. And they're like, ah, I've been stabbed. And you're like, yeah, you'll never catch me, coppers. All right, hot air's coming back. I read code and watched YouTube. Yeah, that's the thing. I made my Super Mimi system, the 6900 and the 5950X, just because I wanted to do like, look at me, I'm a streamer, I'm doing a modern computer. And then I go and I play My Summer Car on it. Similar to iFixit, Jimmy, spring steel, no sharp blade. Oh, interesting. It's just for breaking the edge of cellophane. Yeah, the one I use is the EOD Leatherman that I got while working with IEDs. I like that thing. That knife, I've had that knife for decades. Decade. All right, ship out. I guess we'll do a quicker swap on this one. Where'd the chip go that I was going to put in there? Did I take it out? Oh yeah, it's right there. So I'm going to put the chip down somewhere that it's not going to... Everything around me is plastic right now. And then... which one was pin 1? Do you remember which one was pin 1? Do we have to turn back the clock? These are all facing upwards. Yeah, they got that 45-degree angle on the left. So we'll put this one in like this. You know, I think I'll do the full desoldering. I'll do the full thing. We'll do the full deal. Takes only a second. I'm gonna hold this at a higher angle just so that I don't hit up against any of the plastic stuff that's in the surrounding area. Those two potentiometers are like a specialty potentiometer, and they've got big plastic bodies. I just don't want to even get soldering iron heat anywhere near them. I want them to have a nice long life. You see, this is just kind of tanking up all of the solder that was left on there. And then get the solder over here. Anchor, this pin looks unused, which makes it an absolute terrible anchor because that means that only the surface area under the pin is holding the chip to the FR4 PCB substrate, which is not a good scene. Where did the chip go that I was going to put in? Why am I inept? Oh, it's still in the tweezers. Okay. That's why I felt comfortable putting it somewhere else. $60. What is it, a laptop? Oh, my iron turned itself off. So my iron thinks that it is a cigarette in a bed, and it turns itself off to not burn down the whole house. Which can be really annoying when you go to solder something. Notice how I didn't talk there? Well, oh, careful. I didn't talk there while I was positioning the chip because I was holding my breath. course, then getting the tweezers out of there, I accidentally moved everything around. The handshaking comment I get a lot. That is not an uncommon comment. I don't know what your particular level of handshaking is, but a lot of soldering, and the reason why I have multiple different views here is that one of the most important things you can do is position your hands properly. Soldering and welding are much akin to one another. I mean, one is just brazing, the other is welding, but a lot of the technique and stuff that I show on camera should help mitigate shaky hands. I always anchor my wrists or my palms. Sometimes I'll do like a pinky finger on something just to stabilize. Be surprised that a bother doesn't take the soldering iron to bed with them. Well, you know, they power off after a little while. So it's generally, you know, it's kind of safe. I've never had a dream where I'm soldering something. I've never gone quite that badly. I've had some very, very long sessions of soldering where I'm building something for like a festival, and I never had the soldering dream. Never quite got that bad. Oh, this one's pushed all the way to the side too. Why do I keep doing that? I think it's the parallax of the microscope, you know, influencing me. Multiple sclerosis? Really? Oh, well, okay, or some other neurological thing that makes him shake. I did not know that. No, I have extraordinarily steady hands, so it's kind of a little hypocritical of me to say, of course you can solder. You just put your incredibly steady hands on an object, and that's all it takes. But yeah, I mean, it's good to hear that my techniques actually apply to people with shaky hands, because you want to anchor yourself, right? Your hands have to be in a comfortable position, but if you're touching something, that can help mitigate a lot of the shaking. Now, some people are very shaky indeed, so this is not universal advice. I'm not going to say go out and buy thousands of dollars worth of soldering equipment just to discover that your hands shake too much for it, you know? But within reason, if your hands shake a little bit and it's kind of frustrating, you can try, you know, you can see I'm using my pinky finger here to touch the side of the board and anchor the rest of my hand. I'm doing it with both hands. I've been soldering for a long time, almost on a nearly daily basis, except when I'm uploading videos now. But I've had these techniques in my life for centuries. Ooh, I'm messing up. I can't really get the heat down in there. What's going on? There we go. Okay, new transistors. Who dis? I have steadyish hands, but sometimes they do a thing and ruin whatever they're doing. Oh man. There were a couple of things like that where I was just like, all right, I gotta be super steady. And then your hands just freak out. That was when I was doing the smaller soldering size. I don't think I ever got to the end of that little quip. The smaller sized electronics actually just look like the larger stuff. So it looks like you're totally inept. But what you're doing is you're working with a size that's too small to be worked with. Oh, that's coming off. Damn it. My little tube hanger is starting to come off. Okay. Well, let's see if... My only concern is that I power this up again, and whatever broke the previous set, I mean, I've got tons of the chips. I've got like a ton more of these chips that I can put in, so I guess I'm okay in that regard. But I mean, if I power this thing up again, is this going to break again because whatever killed it is still going on? I tried to solder my laptop hinge back together, and my hands are so unstable, made it worse. Ended up just selling it for scrap at a recycler. Ooh. One of those, yeah, those fixes, the laptop hinge fixes. I've been through the ringer on some of those too. They're tough. Laptops have to take a pretty large amount of abuse. We've had people successfully do the glue with, what is it, baby powder, talcum powder and super glue fix for laptop hinges in order to make sort of a pseudo plastic. Yeah, laptop hinges are notoriously difficult to fix. I don't remember what I did with mine. I think I used epoxy on it. And it held for about 2 closes of the lid. And I thought, I did it. I've done it. I've repaired it successfully. And at that moment, it decided to explode again. All right, how successful we're going to be with this thing? I think we need a significant more reverse engineering. We just got super distracted by a fairly meaty raid. And I love it when that happens. It's a lot of fun because we get to talk shop and I don't have to think. But it does mean that we did get sidetracked on this. Need to let epoxy cure for a week. It might have been JB Weld, which has never really worked that great for me. People talk like, oh, I JB welded a spark plug back into this engine block. Like, I've never had that kind of luck with JB Weld. It's never worked like that for me. Not even once. Okay, so making sure, double checking, this is on the negative lead. Yes, it is. Negative, positive, etc. So we should, by all means, see something coming out of this if those transistors aren't broken. We are plugged in correctly. I've even got the cable running in the right direction according to the image that we saw. What is Twitch stream without constant chat distractions? Well, we lost our main distraction engine here when Burn the Subs filled up. So we've been scrambling to get that running again, especially with all the ambitions that I have for a new version of Burn the Subs. We'll eventually get there, but... Ooh-hoo, ooh-woo, and ooh-woo, bulgy-wolgy epoxy? What the hell kind of perverted fucking epoxy are you putting on your projects? That is disgusting. All right, power on. Heat, 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 heat. That thing's still getting hot. I don't know about this. Is it supposed to get warm? It might just be a chip that gets warm. I don't see heat anywhere else inside of this thing. It's just that one chip. So something leading to this chip is going wrong, or that just gets hot. And the ones that I put in have been unduly blamed. It seems a little warm for what it is. But I mean, you know, look at all the other stuff that's happening outside of this module. Oh my God. Nothing is doing. I could put the scope up on the screen, but it's not going to be that exciting. It's a big wet fart is what that is. It's a European high-quality product. Industrial versions, chemically identical to UHU to UWU 3000. Huh. Yeah, a smaller secondary component. It looks like the chip adjacent to it. I'm feeling heat through the board, so I'm going to turn this off again. What the heck, Dave? What did you do to your frickin' synth? Why do you hate progress? Why are you killing everything? Most of the heat's coming from right there. I mean, there's not really all that much peripheral to it that's heating up. It could possibly be this resistor here. Actually, I can't see what that is at this. Yeah, it's a resistor. But I think most of the heat is dissipated. I can't power it while I don't have the front panel on. I don't know. I need to test setup on this. I need to set this up so that I can actually poke it with the multimeter, and we can see what's going on. The scope is probably more accurate, to be honest. So that would mean plugging this thing into here. And I bought these specifically for this purpose, so we could divorce the two boards. I don't know what direction I want to go with these, like this and the other way. It's like that, like this. We'll pay attention to where pin 1 is. Hook it up to the front. Oh, wait, there's not enough pins on this. Do I have 2 of these? There might be a rogue IDE connector somewhere. I need to find it in order to plug this thing in. Somewhere over here. There's too much stuff on the screen. I can't see what I'm doing. There would be another big gray cable somewhere around that was associated with this project. This project lived here for a little while, so should stand to reason that I have it around. Unless it ended up in a cable bin of some kind, which is also a possibility. Over here by the synth, I see nothing. Okay. All right. All right. Down in the dregs. Looking. I don't know. I gotta look for like cable dumps. I bought 2 of these IDE cables specifically to do this to this module. Oh yeah, scope is not on there. Boop. I need to get that Stream Deck XL to work on this thing, but it doesn't get enough power. And even though it's a powered USB hub, it still powers up and down when it's over there, which is ridiculous. I can plug it into the hub, or I can plug it into the hub that's plugged into the hub, and I get varied reaction out of the thing, but it doesn't work unless it's really plugged in directly at the source. Then what would be the point of it if I can't move it between the desks for when I do game streams and when I do regular streams like this? If I can't move it between desks, then what's the point? I see these other streamers and they've got 2 XLs on their desk, and I'm like, what are you doing with all those buttons? Why can they be happy? Okay, I've got an IDE cable that vanished in the interim months that it took us to get back to this project. Damn, my headache is getting really piercing. I don't know if I'm going to keep streaming or not. Oh! I got to get up and find this cable, though. Let's see if we can find the cable first. The box of fans. It's a box of wires. It became a spillover box of fans. So there's a bunch of AC and otherwise too large fans that don't go anywhere. I should probably like find a home, because those AC fans are super quiet and they move a good amount of air. They're like server fans. They are literally server fans. They're for bigger pieces of equipment. They would be nice to have. This might be the cable. This might be a cable that's the same size. That's a weird cable to have. You should go down on the cable bin. There. Okay, get this back over here. I just knocked over my heat set thread insert. No! No! Oh. Well, you get to do one of those tasks where you organize stuff. Or you could build one of these little robots. There's been screw sorting robots have been the latest thing on social media. Wait, this one already has a pin header in it. Hold on a second. It's like I've done this before. Only one of them has a pin header in it already. Another one with a pin header? No. Okay, all you go away. You are... Is that a different number of pins? I guess so. I don't know. Make room, make room, make room. You coming with me. We gotta find a pin header that's the same amount of pins as this thing. It might be harder than it looks, because I've only got certain kinds of pin headers around. Unless there's another IDE cable up here with a thing already plugged into it. See, we've done this testing before. It's just we didn't get very far. We didn't get very far. Oh, there it is. It's exactly what I thought. The power of fart. Yeah, so this one already has a pin header plugged into it. So you can put both of them on this. All right. Got to hang my mic cable on this light, otherwise I'll end up stepping on it, and when that happens, it gets caught, and then I unplug my mic, and I end up talking for 20 minutes without anybody being able to hear me. So pin 1 also has a little arrow on the plastic, which that would be the stripe pin. In audio, in music, in modular synthesizers, should be specific, the mod synth people call this the stripe pin, even though that's not a stripe. That is just a red pin. The red pin is pin 1. They should call it pin 1. They should be specific about their nomenclature, but whatever. No matter what side the IDE cable is exiting the housing, pin 1 is marked with an arrow. It is also the one on, yeah, in this orientation to the pin, right? So that is pin 1. It's got an arrow. IDE cables do their best to identify everything clearly. So if pin 1 on this one here, on the upper right-hand corner connector, I got to make sure that these are the right... Yeah, no, that goes like this. Jeez. So that one plugs in here. Pin 1 is on the lower... Pin 1's here. So I have to have that match up. Make sure that... is it possible? So if I plug that in this way, pin 1 is now on this side. This might be where things don't match up. Yeah, that's the opposite of what it should be. So that's why we ran into problems with this. How do I undo this? I can undo the cable in the connector and flip it over? What would flipping it over do? Flipping it over wouldn't do me anything. I mean, I can't just plug this in the other way, but that's not going to accomplish my goal. I'd have to put the pin header on like the opposite side. Hold on, am I just dumb? Pin 1 needs to be here on the lower right. So if this pin 1 doesn't meet up with the lower right, it does if it plugs in on the opposite side. So this is the problem that we ran into before, the whole spatial acuity kind of thing, is that I would need contact with this side of the header. If I had these headers that they use, they've got metal that goes all the way up to the edge. And so conceivably I could, if I had this material, I could bump it up against the back side of this thing, and that would create all the connections I needed to. But I can't do that because I don't have that type of header. This looks like kind of an expensive type of header. Do I have that? Hold on, let's take a quick sweep. Quick sweep of what I got. I mean, I've got stuff that could work similarly. Like this stuff has metal all the way up to this part. So if we held this stuff up against the other, it would work. I have to hold it up in 2 places though. And then my dual row header looks like this. It's shielded from connections. Fudge sticks. This is annoying. How can I make a test setup with this sort of thing? I mean, if I create a plug of my own with a bunch of wires coming off of it, that's really obnoxious to do. I really don't want to do that. I could use several standoff headers and make this up so that it's a big ice cream sandwich. That doesn't really work. That's not a good idea. I have those super long headers, these things. These are heavy. No. 3D print a jig that uses the pogo pins. That's a possibility, actually. That's actually not a bad idea at all. Because the 3D printer would be able to handle a 0.1 inch. And then I would have this pressed down into it and the pogo pins on all the individual. And it's got screw holes on it already, too. Sacrifice a fridge. Because then I could have... You'd basically have to go on like that. And this would plug into the other board. Or have the other board so that I could do this. That's a lot of jig to figure this out. I know, as fun as that would be to create, it's like a whole thing. You'd have to have enough depth for the pogo pins that I have, because I do have pogo pins. I have the ones that would actually work really well. Let me get them out. I think they're all the way at the bottom of this thing, though. But that's another piece of 3D design that I'd have to do. It's not a bad piece of 3D design. It's actually quite a simple thing to make. It's literally just a platform. Yeah. Get a Raspberry Pi and hook that up to an Arduino, and then hook the Arduino up to a server, and then 3D print a carbon fiber substrate. honestly, like something exploded due to overvoltage, and we just need to find what that was, and what is killing everything. And I wanted to have space where I could actually hook up, or where I could poke the circuit and see what's functioning and what isn't. I don't know enough about the analog design, though. That's really where I'm stumbling on this, is that I don't know that much about how the M303, the 303, actually works. We have schematics, though, and so I could spend some time looking at schematics, but my analog design is not as good as it could be. Yeah, like I said, I have the pogo pins. Pogo pins. Bonk. And these are the ones that will grip on something like that. What do you mean that's why the FPGA was invented? These have a little like castle on the front. So these are perfect for making contact with something like that. So like, if it were positioned just right, it would hold on to it better. To make adapters between wrong connectors. That's quite a use of an FPGA. The only problem is you can't like solder to these. Actually, niche detected. No, they don't plug into these. They plug into anything that I have. If I had the headers that they use on the other side of the PCB here, these things probably work with pogo pins. A little bit. They almost, well, it actually does work. Yeah, these are very big. I just didn't look at what I was buying when I bought them. It was a sloppy buy. Now these don't work with pogos. I don't know if I really have anything that works with pogos. What about you? Nah, not quite. Not quite. And getting it to work with the IDE connector would be a little bit annoying, but I don't know. That would be a method to really over-engineer this fix. I don't think I really need to super over-engineer this fix. All right, so we're at an impasse. We're at an impasse where I'd like to be able to test this thing, and I don't want to do a ton of soldering in order to make it happen. I could desolder those connectors and solder them in upside down, and then I would be able to use these cables. I'll have a think about what exactly I can do in order to utilize the ribbon cables, because it really should be 1-for-1. But I guess it's not. One of them needs to be flipped, because pin 1 goes to the opposite end of that. So if I flip this connector, that's not going to do it. No, they're not like a mirror image of one another. How are you supposed to do that? If I flip the connector around, then the stripe will be over here, but it'll be on the other side of the cable. So maybe I can pop off the cable and... No, but that doesn't switch the... I don't... Man, my head hurts. Dave's synthesizer dies another day. It remains dead for another day. I'm going to have to come up with something that will help me figure this out. And I don't think it's a matter of like... I mean... I don't think I'm contributing to the community if I actually make a full schematic. Yeah, the IDC spatial recognition thing always gets under my brain. My brain can't handle it. I'm turning the scope off though, because it still doesn't work, and we don't know why. We haven't made any progress with it. We had fun today though. I mean, I had a good time. I hope you guys did. I'm going to be back on Thursday. It's like, what day is it? I'm going to be back on Thursday. We're going to work on Burn the Subs. We're going to work on Burn the Subs at least one day a week, just because we haven't been making much progress. We haven't been making much progress with anything. I made a little bit of progress in my knowledge of 3D modeling car bodies, because I am totally in control of my life, and I didn't fall into a like a dopamine circle with that. But I think the thing that I want to try is actually going to work, though, using the shelling function in Fusion. You didn't even get out the troubleshooting hammer. The American Nutfucker can stay in the drawer for now. That is my polarized, no, what was it called again? Nah, whatever. I've got it labeled, but it's, yeah, that can remain in the drawer for now. I really want to get this Dave synth working, and I don't know why that cluster of transistors is heating up. It could be something else down the line. It shouldn't totally be, no, 41414 is the intro length. But yeah, I'm going to be back on Thursday. So those of you that still remain, how many did we hold on to? I know there's a couple chatters, but it's really those lurkers that I want. Hey, we still got a really respectable number. Thank you guys for joining me. I probably should see if there's anybody else to raid. That would be the responsible. I'm probably not going to raid anybody though. And Rabaz, oh, he's doing Valheim? Was there an update? We didn't play Valheim this time. We've had too much seat time. Ella's doing My Summer Car. Oh no, Grand Theft Auto. Andrew Physics Twitch doing art. Just drawing on foam. That sounds kind of cool. So anyway, you guys can check out whatever you want. I'm gonna leave you guys to go to whatever stream you feel like going through. I want to thank Cosmo Quest X as always for rating, as well as I'm not looking over here to see who it is. Jackie_codes. Jackie Codes. Thank you for the big raid. I really appreciate that. We haven't gotten one of those in a while, so it's kind of refreshing to have a big crowd suddenly forced to watch your every machination. Here's the end card. You guys can find my social media and a link to my Discord. I'm mostly on Discord. That's where you're going to find stuff that's going on in the background, a lot of the project updates and stuff, and people sharing their stuff that they're working on, because I'm more interested in that than I am my own projects. I'll catch you guys there. Until then, I don't know,